And last meeting, we did talk about one of the problems was that libraries, you cannot understand most libraries. So you have to trust them. And it's my goal to write my own libraries, but it's very difficult to share them between systems.
Mm-hmm. Well, we actually have the FORTH.net website, and I can talk about that, how easy it is to provide libraries there. So, but that's not for now. It's for next month, maybe.
Okay.
So I guess we start today's meeting. So Peter.
We started, yes, excellent.
I started the recording already, and so we're ready to go.
Excellent. Are you going to present the first part, Ulrich, as ever?
Yeah, I can do that.
Okay.
I thought you would say the welcome words because organization is mainly your part and our surprise guest as well.
Well,
yeah.
The meeting today is divided in two parts. The first part, as we do normally, we present different folders from all over the world. We have the people always from Australia, Taiwan, then we go to Moscow, Europe, and we go then to other countries in America. We welcome very much everybody here who is maker, who is new in the community. We are all programmers. We know each other from many years, talking in different chats. And the FORTH community welcomes everybody. And we start the meeting now with Ulrich Hoffmann from Germany. He will present the first part.
Mm-hmm. Okay, great. Yeah, so here we go. So, Jos, you had already some comments on our discussion, and now we will go and hear your talk, how to start working with Cforth. I think that's very interesting. And so if you're prepared to show your slides, then you can share the screen and also open your microphone, and then the stage is yours.
Sorry. Okay, I'm trying to share the screen.
Yes, we see it.
Okay, thank you. Even kijken.
That's the one with the black screen right now, and the yeah, here we go.
Okay, I'm going to talk about Cforth on an ESP12F. My goal is actually to write to control small applications over wireless net connection. It's important that it is flexible, and speed is not always important for me. Here you see a typical application. Here is the ESP12F connected to a switch, and if I open the window, then I can see on the in my room if it's open or if it's closed. Now, and this is actually the ESP12F with some features. It has, of course, a CPU. It's able to connect over Wi-Fi connection. It has an EDC unit, and it supports, of course, UART, ADC, PWM, and I2C. The GPIO, yeah, in theory, you have 11 connections, but in practice, you will only have 5. The remainder of the GPIO is used for other functions like reset and that sort of thing. There's also 4 MB flash memory, and it has 36 kilobytes of RAM if you are connected over, if the CPU is connected to a Wi-Fi unit, to a router, sorry. It uses only 71 milliamps at 80 megahertz. And most important, it's easy to solder and to adapt to a breadboard. And that's, of course, very important if you want to solder it quickly and place it in such a unit. Now, then I would like to show you how it looks in practice. Here is one. That's the CPU, of course. And if I reset it, then you will see the system LED that's blinking, and after a while it doesn't blink anymore, and that means the application is running. There is a lag in my network of about 1 second. So if I talk and I do something, you will see the effect 1 second later. Oh. And then about Cforth. Even kijken. These options I will show you in a minute. Moment. Well, to get to the unit, I have to go to a Linux PC. I have set up several shortcuts, so I don't have to type much to get somewhere in the system. In this case, I would like to go to the unit, and I can simply type pi for PyCon. That's a terminal program, and here it is. If I reset the unit, then it will restart, and there is Cforth. Now, Cforth is a 32-bit Forth. It has a primitive file system. Here's how it looks. I have already put some files in it. It has a debugger for single stepping and that sort of stuff. A decompiler. Here is how it works. It has a floating point unit on it. And very important, it has FreeTOS. And with FreeTOS you can do a lot of stuff like preemptive multitasking. It's multi-platform. And if you want to know that, a moment. Oh, he's playing. Even kijken. Oh, so much Windows. Even kijken. Here they are. Even kijken. Waarom is het zo? Nee, dat kan je ook niet zien. Even kijken. Ah, maar... Enfin, as you see, there are lots of of systems on which you can run the system. It's about 20 or so. Even kijken. 5. An option of Cforth is so-called sifting. If I type sifting and add a word, then it shows all the words that are similar to the word words. And that's very handsome. You can very quickly see what it you can very quickly see what words are similar. And if you select one and simply do this, then you see all the words. And the same is for if I made an alias, FIC, oh, sorry. Oh, doesn't work, sorry. FI is, nee, dat is goed. Sifting, oh, sorry. There it is. Simply click, C, and you see the word C. There's also a start file. That's what complicated. It means if you boot into Cforth, it starts that file. And I can show that if I reboot the system. That hello Forth is actually compiled at the word start. It does now nothing, but it's very handy to start an application, and you will see that later. Of course, it's also possible to communicate over a TCP connection, and it supports also the items like UART, GPIO, ADC, PWM, and I2C. And it also supports UDP, and that's also very important if you would like to transfer the file very quickly over a TCP connection. And of course, there's Wi-Fi support for Wi-Fi connections. I made a few additions, and I will also demonstrate them to you. One is extra.fth, in which I added a number of primitive tools and a number of HTML tools. A simple logon to a Wi-Fi router. And I will show that one to you. If I restart Cforth, then you will see this line, and that means it is already connected to the Wi-Fi unit, to my router, sorry. And it's completely automatic. I don't have to do anything. Then there is an RCV file.fth. That's the system I use to push a file through the network to the ESP unit. Now that greatly reduces the development cycle. I will show that in a minute. And there is of course tasking _RTS rtos.fta for preemptive multitasking. I have also a demo for that, and that's where we are going to start. Okay. Trouble with the screen. It's hiding something. Even kijken. Kom ik daarbij? Select. I have to break the screen because there is a menu bulk before my pictogram. That's a bit stupid. Even kijken. Oh, wait, here it is. I have already started an upload server, and the upload server is actually the program that I use to push a file to the ESP unit. To receive a file, I have to push enter the letter R and enter. Then the receiver is started and it's waiting for a file. The first thing I have to do is to push the save button. If I push the save button, then you will see here there is a report sent to the server. And if I see it, then it says the connection is successful. That means I can send a file to the CPU. I push send. I found it found. Sorry, I have to push this one. Update and then hello, save, report, send. There it is. Well, that was 2 seconds, and that's quite fast, I think. And if I load it, that's the next option, then it restarts the CPU. And again, I have here hello. Now we're going to change it. Here we are on the Linux PC. I made an entry demo of a map demo, and here is the hello CPU of the hello.fth. The test case was 0. 0 means do nothing. I change it now to test case 1. That's a simple thing. It says hello. I save it. Go to the okay. Oké, even kijken. Nou, een small screen dus zo. Debian. Oh. Nou, een restart receiver. Hallo. The connection is okay. I sent it. I load it. And here's hello world because I changed the file. There's also another option. I can put the whole receiver in the background. I need to restart Cforth. Well, that's done by pushing the button. It restarts. And now you see here in the background that the receiver has already been started. That means I don't have to start it manually. It already is there. If I push save, then it tells me report has been sent. And here I receive the report. So I can send again the file. And here I see it has been received. I also see it here. I can load it. And again, there it is. And that is what I mean. You can shorten the development cycle. Well, the next step is to show multitasking. if I want to show the multitasking demo, I have to remove the program, the receiver, from the unit, otherwise it will hang. Sorry. Okay, I need to restart. Okay. And now there is no CPU of no receiver running. And I'm going to change the source. The tasks are in test case 2, so I change here the value in 2, save the file, start the receiver, check the receiver, send it, and load it. And there's the multitasking demo. It has a faster, slower, and a very slow counter. And as you can see here, there's also a LED blinking. This, what you see, is the monitor. I stop the monitor by enter, and you see here, the LED is still running because it's multitasking. I can enter words, and while words is running, it was still blinking. And that's the nicest thing of multitasking, in my opinion. Even kijken. Now, it's also possible to change several programs with the receiver. I kill all tasks to stop interfering. See, the LED has stopped. And I restart the receiver. And here I'm going to change to the ADC server. Save report. Connection is okay. I can now send it. Well, it was half a second. I can load it. Now it's compiling. And it's listening. It's on this IP address. Well, here's a link. And here's the ADC receiver. If I press read the ADC server, the ADC server, then it reads the ADC port. Now, nothing is connected, so it will show some random values. If I would like to change the program again, then I simply push update. Here you see the receiver has been started. And oh boy. Oh, nou ben ik het kwijt. I have some trouble with the tablet moet ik hebben. Oh, even een andere way, sorry. Even kijken. Simple. Refresh. Refresh. 2, 3, 4, 5. Ah, daar is mijn receiver of mijn sender again. And now we are going to change the program from IDC server to the Wi-Fi card demo. I save it. And you could see here there's a new report. Now I can load it. Ah, something went wrong. Even kijken. Okay, there it is. Now I can load it. And now watch. Oh, extra.ftr. I missed one file, sorry. Oh, moment. Kijk, dat is in beeld. Dit is Debian by. Oh, but it was there. Oh, that is pity. Kijk, ik kan het openvouwen. Dus dat betekent.
So, Jos, maybe you can talk about what you want to tell us, because I guess we're losing a lot of time with trying out what's going on.
Yeah, I will short it, make a shortcut. I have here.
That would be great.
Even kijken. Okay, this one runs, and here you see if the setup was right, then I can change very quickly between two applications, thanks to the fact that there's a connection over an UDP connection, of tenminste een UDP connection. Even kijken. Even kijken, how to extend? Well, I've run out of time, but it is possible to put programs in ROM, and that means you don't have to load it. It's already there when you start Cforth, and that's a very powerful option. Now, there's limited memory that can be solved by putting words in the dictionary in ROM. You can use the file system and avoid allocate, use allocate and do not use a lot, because that takes memory. There's an option to see the memory, and that's called .free. That will show you the free memory in RAM for code and the free heap memory in which you can put data. Kijken. And then the last slide, that's about the installation. If you started under Debian 9, then you need to install Python 3, and then you can clone Cforth, use supervisor options, go to the build directory, make it, and then you can flash it right into the ESP12. And that must be done in one go. If dependencies are missing and you need to correct the setup, then it's possible Cforth will not run. In that case, delete the whole directory, inclusive the RTOS directory, and make it again, and then it will run. all editions are also downloadable from my homepage below. And that was all. Are there any questions?
Thank you very much.
Thank you, Jos, very much.
Yeah. Other questions? Open your mic and go ahead, or raise your hand, whatever you prefer.
I have a question. I see the name Mitch Bradley. Does that mean that Cforth is a product of Mitch Bradley? And why didn't you mention that at the beginning of your lecture?
Oh, you're absolutely right. It was made by Mitch Bradley. Well, I thought, yeah, I didn't think about it.
Yeah, if you present want to do a presentation, you should think about what your audience doesn't know. It's just a remark. That's all I have to say.
Okay, okay. Thank you. Yes, you're absolutely right.
So are there any other questions?
Just a quick question here. I was reading some of the interesting comments in the chat, and there were a few kind of, interesting points about how Forth kind of competes with MicroPython. Not really competes, but the idea of how platforms like MicroPython are very attractive to beginners because it's so easy to just get started and move forward with it without having to reinvent the wheel a lot yourself. What was your experience like getting started with Cforth on the ESP?
Oh, well, it was a bit hard because the first time I used it, it wasn't actually right. So I talked a bit about it with Mitch, and eventually he made a version that's running on the RTOS, and now I could use it. And for me, it's important that I can use it, take a chip, put it on a PCB, and then it must run. And I don't want all kinds of development boards because they take too much room. So yeah, but once all the problems were solved and I have my upload server, then I was quite satisfactory.
I will say something for the community. Can you hear me?
Yeah.
Well, Jos is one of the most important people for me in the community. He's a professor. He explains everybody in a helpful person. And we are very glad for this presentation and hope new material in the next meeting. So thank you very much, Jos.
Okay, I will.
Right. So yeah, thanks. And so we have to see, because of our special guest, that we keep in time so that we don't keep him waiting later on. Our next speaker would be Demitri Peynado about metaprogramming. And Demitri, are you there? Are you ready?
Yep, I'm here.
Great. And so we hear you. Well, there's a whale or wow in the background. Yeah, and so you can share your screen and give your presentation.
Let's see. I'll share my window if I find the right one. Okay.
Yeah, we see Meta 2 as an article in a PDF previewer.
Okay, great. I think I'll start from here actually. Originally, I was going to skip a lot of the parts on meta and focus on Forth, but I realized if I did that, no one would be able to really follow along with what I'm trying to achieve. So I thought it might be worth taking just a little bit of time to go over what Meta 2 is, and then I'll go to what I did with Forth, which is the main focus of my presentation. So Meta 2 is a compiler writing language, which was originally designed for Algol 60. You have to remember when Algol 60 came out, compilers were quite new. And this was a big language with many features. So any suggestions on how to compile it were welcome. So this author, Duyval Shaw, had an idea, which was to create a language that looks a bit like Bacchus normal form. I don't know if in the audience you're familiar with Bacchus normal form, but it's just a way of describing the syntax of a program. The difference with the meta is that there's little instructions to inject assembly as an output, little assembly codes. And the way that Shaw approached it was to write an interpreter actually for each language, and what you would compile to is a virtual machine, and that's what you would run your programs on. So it has a few built-in things. Direct matches with the source program are shown by things in quotes. The slash is represented by alternation. So for example, a logical value is either the word true or the word false. It can also identify things like identifiers, which I think follows the Pascal definition, which is a letter first followed by letters or numbers, strings, which are in single quotes, and of course numbers. There's other features too. So this is a simple example for arithmetic expressions and how that would kind of look in the syntax. As you can see here, these are kind of procedures that call each other. So EX2, you can pretty much insert the body of that here and get the same result. Just like with Bacchus normal form. I'll show how that translates to Forth later. But eventually you get to solid things like this ID here, which checks for an identifier in the input. This checks for, left parenthesis and so on. Now, the interesting part is these output expressions. So again, with this as an example, it looks for the expression, but when it matches, the compiler will output an assembly instruction such as multiply or add, as well with as the numbers it matched. So it's a very simple way of compiling a program. But if you also can write your own virtual machine, this could have been attractive to somebody at the time. So I think I've covered probably enough of that. There's a number of examples at the end of the paper, which are really tiny, of how things look in Meta. The interesting thing about Meta is it can compile itself. This, oh, sorry, that's not it. Here we go. Meta 2 compiler written in its own language. So this describes the syntax of Meta 2, but it's written in Meta 2. That was quite a surprising thing at the time, a new concept of this meta compiler, that you can have something that describes itself. And it's one of the things that makes it so fascinating. So now I will show you how I did this in Forth. I forgot to present, that's the button, okay. So yes, I've covered this. That was my original slide. So what were my personal objectives with this? Well, it was to implement the instruction set of the Meta 2 virtual machine using Forth. Meta 2 itself has a virtual machine that runs on, but it's some made up virtual language. I wanted to use Forth so that I can compile programs to Forth because it's quite low level and it's easy to write words which kind of resemble a virtual machine. And another thing was to write the Bootstrap compiler, meta compile. You know, where do you start first? A compiler can compile itself, but you need a compiler to begin with. So I'll show you how I managed to do that. And finally, to prove that it all works, compiling an example from the original paper into Forth. I'm hoping to do a live demonstration at the end of this on that. So let's start with the virtual machine. Now, the good thing is it was incredibly simple because a lot of the original features of the virtual machine were not needed when you use Forth. For example, you don't need to use labels. You don't need to use call or return because Forth already handles that by words. You don't need special address retrieval instructions because variable already does that in Forth. A lot of these things were already available to me, so the number of instructions required was reduced by 37%. And this is the listing here. For this project, I chose to do a single line approach with Forth. I don't always write this way. Sometimes I pretty print it, but this allows it to fit on the screen quite easily. And I pretty much went from the descriptions given in the paper. If you said something like delete blanks, I just created a word called delete blanks, which basically removes white space. Also words for checking for digits, for letters, for quotes. I tried to make it relatively understandable, at least for myself. Of course, when there's a match, so take, for example, number, you know, if you have a digit, we want to be able to record that digit somewhere. So this is what this save function does. I'll come back to that in a moment. So these are the support words. I won't go through this too much, but this code was also part of the program in terms of building up that virtual machine. And it's mostly things like removing white space, checking for certain symbols. But there's things that are not so clear to do with replacing quotes, and as well as the save mechanism to be able to save your matches and to be able to remove them if necessary. So yes, now I'll explain the challenges I had and how I overcame them. So in Meta 2, if you remember, strings have single quotes, but they need to be converted into Forth, which does S quote and then ends with another quote, double quote, that is. Now that was, I didn't expect that one to come up, but it did come up because you would match with a string. And the problem was that if you output it then into the Forth program, you still have a string with single quotes. So I wrote this little word here, which is probably not the prettiest one, which converts single quotes to Forth quotes. I gave it a name that made sense to me, you know, single quotes. This is normally means two, S quote, double quote, double quote. And it pretty much does a textual replacement of the single quotes and so on. The next one was to save matches but be able to backtrack. Okay, so let's say you have you're trying to match the word hello or hello world, and what's actually in the program is hello everyone. The part that says hello is going to match, but you didn't match the whole thing. You need to be able to go backwards in order to check that another thing matches with it, right? Otherwise, you're going through the input without giving it a proper chance to match. So the way I managed to kind of backtrack was have a save and restore point. So save, well, records where you were in the program. It's just an address, just a pointer. And I had one thing which was end save, which would then immediately copy what part of the input you were looking at so far. Or if it didn't match, I'd use restore, which would just take the original pointer that I saved and retrieve it. So you can see it's used in certain things like test, which tests for a direct match. If it matches, so you save first before you do any matching, save. You do the match. If it does, great, finish saving and then record the match. If the string doesn't match, then you do a restore, which just sets it back to the point it was before it started doing the comparison. Okay, so what about the bootstrap? How did I get this going? Well, I've shown you this before. This is Meta 2 written in itself. I couldn't use this format exactly. There were a few issues with it. See, one of the things is that the output needs to be structured in order to work with Forth, or at least I wanted it to be structured. I want to get rid of branch to this location, branch to that location, and so on. It's a lot nicer. And one of the things is Meta 2 is not just recursive, right? So one of those syntax equations can call itself. Meta 2 is also mutually recursive. So one procedure can call another procedure, which calls the original procedure. It's really confusing. And this, I didn't know originally how to solve this in Forth. Now let's see how I managed to solve it. So for the branching and stuff, I just use typical Forth words: if, then, begin, until. They're all familiar with us to us. It makes the output a lot more readable as well, although it's not very readable anyway because it's a compiler output. And one thing I had to do to solve the mutual recursion problem is to declare the name of the word or the syntax equation before I used it. And I've discovered defer, no name, and is. So what defer does in Forth is it allows you to declare a word that exists, and then later on you can give the definition. You don't have to give it at the same time. So what this allows you to do is normally if you have not declared a word before you use it in Forth, you get an error. If you've not defined it. With defer, you can say this word exists, so the compiler will allow you to use the word in another word, even though you've not given the definition yet. With these changes, I changed the way that Meta 2 looks, and I went for a sort of Pascal approach because Pascal is quite similar in that you have to declare things before you use them. And so you have these things called rules, syntax rules. This is the name of the rule. At the end, I put the name as well because it makes it easy to, for is, which requires the name of the word you're defining. And I've even indented it to give it a bit of structure. So this is Meta 2 described in my version of Meta 2, if you like, their equivalent. And if you look closely, you might notice that it is outputting Forth. You can recognize things like begin and until. Some of the instructions we looked at earlier. And right here is no name and is. So the next thing I wanted to do, of course, was to compile an example. Otherwise, how do I know it works? Although it has compiled itself at this point. But we don't want to just compile a compiler. We want to compile an actual language. What I'll demonstrate in this presentation is a Valgol 1. It's like a really tiny language that's based on Algol 60. Some key differences, but it's enough to kind of illustrate the compiler. So here's the program. And this is what we expect it to output. It's just plotting a graph of x squared divided by 10 plus 1. So this is what I was working on compiling. This is the original description of the syntax. So this here is a compiler for Valgol 1. Though it can compile the language I've just shown you before, but it's written in Meta 2. So you have to actually compile this compiler using Meta. I managed to rewrite this in my style, so it looks more like this. And maybe I can pick out an example of here of one of the things I was doing. So for example, an identifier, an identifier is just a name, like for example, X. What I would output in Forth is the thing that matched. That's what star means. So X at, because that's how you get a value from a variable in Forth. With numbers, I just output them straight away. And let me see if there's any other interesting ones. Of course, an assignment. So assignment in this language is a bit strange. The value you calculate is on the left, and the thing you're assigning it to is on the right, although that is quite like Forth. So it is very simple to do that because you just output the expression. So you calculate the expression, you output the name of the variable, and you do exclamation mark is the typical way that you would write that in Forth. So now I will do a live demonstration. This will be exciting to see if it actually works. So first thing we need to do is actually include meta, which I've just done. So meta's in the system now. Then we want to load the compiler for valgol1. So valgol1 txt load. Load is defined by my meta thing. It just puts the program in a buffer. I'll show you. If I do source 100 type, so it's just typed out part of it, but you can see that's inside the buffer. Then we want to compile it. So we do, let me leave a little space, program. There we go, it's compiling the compiler. And that's it. So I'll just copy this. There's probably a way to automate it a bit more, but this is visual and easy to see. So you can see where I've used things like defer. I'll just show a bit more of that quickly. So these are the names of the words and I defer them. And later on, I define, when I have the definition, I assign it using is. So this allowed me to solve the problem of mutual recursion. I won't go into explaining all of that for now. If you ever have a problem where you have mutual recursion, defer no name is, just look for those and you'll be able to solve it. Okay, so let's now load this compiler into the system. Run script, that'll do. So it's loaded that. Now we want to load the source program. So if I go here, I have something called valgol1 example. And I'll just show you that's in the buffer. So there you go, that's the program I showed you on the slide earlier. And all I need to do is type valgol1 and it's compiled it. So this is how it looks in Forth. So yeah, that is the fourth version, fourth translation of this program here. And of course, does it actually produce the same output? Well, let's give it a try. Run script. And I should be able to type run. And yes, we get the same graph as before. So I'm very surprised that this live demonstration worked. I expected something to go wrong. So that is actually the end of my presentation. I will take questions. I have kept it quite short. Didn't want to cover everything this time. Let me drop this link into the chat because this is a web version of the original paper. If anyone's interested, you can have a look.
Thank you very much. And of course, your source code is very welcome. I think many are very excited of what you did. And great that you ported it to Forth. I was aware of the paper, but never had the idea of doing it that way. Great. Are there any questions to Demitri?
I have a
I just
question.
have a comment. Oops,
Okay.
go ahead.
Yes.
The Meta 2 language itself, this is kind of fascinating. It has some interesting similarities to sort of a lot of the sort of core ideas in Forth in some ways. Do you know where did this line of research go in terms of sort of what you could imagine interleaving, describing the syntax and then using that syntax and so on. Sort of, it seems like an interesting line of thought.
No, it's pretty fascinating. I think there were some compilers developed from this one. It was a beginning of the compiler writing languages. It wasn't meant to solve all the problems. So somebody came up, different author, came up with a version called tree meta, which is even more powerful because it creates an abstract syntax tree of the program and then operates on that. So it's a lot more powerful. I might be mistaken, but it seems as if this author, Dewey Val Shaw, eventually became a Forth programmer, because I was looking through Forth dimensions and I was looking for how to do modules in Forth, and there you go, someone by the same name. Could be coincidence, but I figured it perhaps is quite possibly the same person. So there's a possibility this author later became a Forth programmer. So this is before Forth, so they would not have known about Forth, but I guess their thinking made it easier for them to get into Forth later, if that really did happen.
Mm-hmm.
You're correct. He's one of the old timers.
Oh,
Right.
I was just going to comment on the fact that it can define itself in a very terse way. It's very, very compact from that standpoint. That means it's relatively complete.
Mm-hmm.
Yeah.
Mm-hmm.
I wonder, how long did it take you to develop the software?
I thought someone would ask, and I didn't keep track of how long, but it was a little over, maybe like 2 evenings or something. I don't remember spending a long time on this. Researching and solving the problems was the hard part of how to do mutual recursion and stuff. And I looked to, there's a tutorial, I think it's called like Let's Build a Compiler. I've forgotten the author's name. Mm-hmm. But someone managed to do this tutorial in Forth, and I said, okay, they must have solved this in there somewhere. So I looked through and I discovered, oh, they used defer. That's how they managed to solve these problems, because if you're writing any compiler, you have these same issues.
Mm-hmm. There's a question from Philip Eaton in the chat, and he says, great presentation. What are you going to do with it?
That's a good point. Yeah, what am I going to do with it? This is mostly for demonstration. I do not write Forth this way normally, to compile things into Forth. That was originally how I thought Forth was used when I came across it, because I thought, who would write in this language? It seems strange. Now I just write in Forth, and there's a lot of power in that. I might be able to deliver a presentation next time of what happened when I tried to compile a language which was much closer to Algol. The main thing is it revealed how different Forth is from those Algol languages, which include C and
Right.
descendants.
Mm-hmm.
For one, it could be used to translate one language to another language.
Yes, and that's been done. There's a web page as well where someone has, I think they compile things to JavaScript.
I have a similar experience to yours, not using Meta 2, but the very first Forth I wrote back in the early 70s used Stage 2, which is a very powerful microprocessor, to generate, see a word, translate it to code, and behind it other words would look at it and say, hey, this followed by this, I can do better, I can generate. So it would even optimize the code. And so I really like doing non-standard ways of doing things, and your approach seems interesting.
Yeah. So Albert is raising his hand.
Yes.
Albert, please go.
Yeah, I've been dabbling with defining languages in Forth also, and I went from the other side, from identifying the keywords and the other things, the numbers and the command, etc. And I can define the whole of Pascal in a half page. And if I think it would be nice to combine these facilities with what you do, because then it will become even more compact. What my point is that if you have keywords, then they should be looked up by Forth, not by a separate mechanism. And if you do that, you get a very compact and very elegant parsers. And also, I'd like to port the program to Cforth, because I have already installed a very simple mechanism for mutual recursion, and also for parsing strings like those between single quotes. So I will certainly look at your website.
Yeah, that could be done. I will. Oh, I need to make the source code available then. I have more interest than I thought.
Yes, please, please.
Perhaps I can put it on GitHub, and then maybe I can post the link on the Facebook group.
That would be
great.
Yes,
this was a wonderful presentation.
Yeah, thank you very much. Thank you very much. And so looking at the schedule, our next speaker will be Howerd Oakford, and he will talk about ColorForth. And I admire his talks very much. And today he will talk about ColorForth in black and white. It seems to be a contradiction, but we will learn about that. Howerd.
Okay, thanks very much, Ulrich. I'm
Okay,
here.
great.
Can you hear me? Yeah.
Yep.
Can you see me?
Yes.
Okay, I can't see myself on the screen. This is a feature.
Welcome, Professor Howerd. Another great further.
I'm no professor. I just work for a living. Okay, before I start, I'm just posting a link into the chat, which is a link to my ColorForth page. So everything that I talk about, you can click on that, and hopefully the links will work. I've been working hard to make sure they all work, but please let me know if there's any that are out of date. Okay, I will share my screen. Okay. That's the chat one. Okay.
Oh, that works. A text editor.
It's a text editor. Good. Okay. What I wanted to get to first of all, here we go. This is the source, ColorForth 2019 in net wide assembler format. This is actually the most up-to-date version, more or less, and this is from April 2019. I didn't manage to produce one in 2020. If I had, it would have been called CF 2020, and this year I hope to produce one called CF 2021. So anyway, I just wanted to point out that I didn't invent ColorForth. It was invented by Chuck Moore and ported to the GNU assembler by Mark Slicker, ported to NASM by Peter Appelman. John Como did the BIOS boot in his version, which I used as a starting point to get my version to work. Okay, let me go to the PowerPoint, if I can find it. I thought I had it open, of course, but as the way things go. Right, I hope to explain why it's ColorForth in black and white, i.e. ColorForth without color. That makes any sense at all. First, I got to get PowerPoint. It's amazing, isn't it? I have to hide the Zoom screen sharing menu in order to get to the slideshow, in order to say from beginning. Right, can you all see it now?
Yep.
Great, thank you. Okay, so this is it, ColorForth in black and white. So let me launch with this. Right, what you're seeing here is the ColorForth logo or screen that comes up when you power it up. ColorForth has some interesting features, one of which is that you don't use the normal keyboard, you use the keypad, which is this little item here. I don't know if you can see my, oops, sorry. I've done something interesting to the system. Oh, look, I've gone down a page, right. Right, I'll explain more about that later. Right, ColorForth, a short history. Chuck Moore developed it in the 1990s and released it in the public domain in 2001. So I just searched various sources on the internet for this information. Now I came across it, presumably, it's a long time ago now, shortly after Chuck published it. And I got involved, and in those days, everything, all these early ColorForths, they all ran from a floppy disk. When I was preparing this PowerPoint, I wanted to find a ColorForth floppy disk so I could take a picture and share it with you. And to my horror, I don't seem to have any. Maybe one of you guys has one from that time. Anyway, I created one, or an image of one. I did have a floppy disk, which you see here, and I created a label that looks similar to the one that I handed out at Euroforth 2001. Okay, so ColorForth now is still being actively used by green arrays. Just clicking to their website. So this is Greg Bailey and team, and they produce the GA144 and other chips, which are the most amazing chips. And the chips are developed using their own version of ColorForth, which Chuck did for them with some help from various other people. I don't know all the names. Now I have a link here, hopefully, that I can find quickly to this one. So this is ArrayForth, the green arrays version of ColorForth, and they've done various things. The first thing they did, obviously, they created an extremely clever system whereby one program works out as it boots, is it being run from an actual floppy disk or is it running under Windows? And it works in either. So they also gave you the option with this quer word, which is short for QWERTY, to operate with a conventional keyboard rather than a keypad. So if I type soft sim, this is one of my favorite little apps here. This is actually the GA144 simulator. So if I type go for this, it should start. Okay, so what you're seeing here is each of the little blocks that you see flashing in various colors there, that represents one of the GA144 F18 cores, and there's 144 of them.
Howard, sorry, but we see the screen very small and your head very large. Can you switch that?
I hope so. Always a technical problem here.
No, it's fine with me. So probably, but it's.
Okay, that's the problem with me. Thank you.
Okay, no problem.
Yep.
Okay. okay, the important thing is, can you all see the what is happening here is each core, and I don't want to spend too long on this because it is a ColorForth. It's a ColorForth used to create a chip, and the chip executes an instruction set which is sort of like ColorForth, so it's connected. If I just press the F key, then go again, then it goes really quickly. Now you can see that each of the 144 cores is in the top right hand corner, and what is happening is that the code that is executed on one of the F18 cores transfers code through itself to the next core in some way, depending on how it's programmed. And I find this whole thing extraordinary. But anyway, that's not what I'm here to talk about, so I will stop this, but you can follow the link, download the code, etc. And this is the word you need to execute. It's all very easy. Okay, so if I exit from this, I think the easiest way is to close it and come back to my PowerPoint and find it somewhere. Right, okay. Now, there's also other people have used the ideas in ColorForth. One of whom is Pablo Reda, and he's produced this R4, or it keeps changing year by year. I hope I'm reasonably up to date with what it's called this year, Pablo. But this is also excellent work, based very strongly on ColorForth. Okay, and then there's me, of course, and I do. This is my web page here, which you'll find, and it should be reasonably easy. And I wanted to just try this. If I click here, I downloaded the Forth. This is unfortunately Windows only. I'm sorry about that for people that don't like Windows or don't have it. So you then click on OK. You then choose a folder. If I call it Zoom, there you unzip it, and then you click OK, and it opens and it runs. So what this is a version of Chuck Moore's ColorForth adapted so that it will boot using BIOS calls rather than actual hardware, floppy disk hardware, because I've also found when I was hunting for the ColorForth floppy disk, I also realized I don't have a floppy disk PC anymore. I thought I did, but I must have recycled it on our last move. So okay, that worked. This is extraordinary. So what I've just done is I've collected the ColorForth system in a self-executing zip file. You may or may not be able to use that format these days. I was able to just now, but depending on your antivirus system, self-extracting zip files are really can be very harmful. So they tend to get stripped by various parts of the system. But anyway, it managed to work. Okay, so here we have ColorForth, and you can see it's in color. So the next thing I wanted to show you is that one of the things that I added to this version of ColorForth is the F4 key, like so. And if I press F4, oops, sorry, I pressed it twice, it went back. What you'll see now is the same ColorForth block, and this is all based on 1 kilobyte blocks. Excuse me. And it converts it into a conventional ColorForth. So you can then, with this, I've also added, apart from the F keys, which do certain things, F1 is a help screen, and it goes through various help screens that are available to you, explaining how to use things. F2 does something else, and F3, it's all in the help screen. So the F2 toggles hex and base 10, F3 toggles the C blue. So there's a blue color token here, which you can turn on and off. And this allows you to format the text in a ColorForth block in a particular way. So you can see here that every CR puts in a new line, because in the earlier versions of ColorForth, not my version, the new line is only produced by a new colon word. Okay, so I can turn that off. I can go back to one of the other blocks. Oops, sorry, I'm I'm panicking and hitting the wrong key, of course. Let me try and get out of this. Go back. Right, so here we are. So you can also use the arrow keys to go to a particular app, I think is the word these days. So here we have, for example, I scroll down to it, life, and this is, sorry, scroll back up to it. One problem with what I'm doing here is I'm running the ColorForth system under Box, which is a kind of real PC emulator. Anyway, it's very slow. If you put it onto real hardware, then it really goes very fast. If you want to see what the speed is really like, then it's you go to the Green Array's ArrayForth, and that's because that talks directly to Windows. Then it is fast. Okay, so I hit that, and this is Conway's Game of Life. Also, not the fastest in the world, but I've put in a random function there, so you can make things happen quite easily, if not very quickly. Amazing. I don't know quite what's happened here. Okay, this is a great opportunity to go back to my PowerPoint. That's a great opportunity to exit. So to exit ColorForth, if you're actually trying this, this is amazing. The curse of the demonstration strikes again. I can't even type on the keyboard at the moment. Right, okay. Bye, you have to say, but not in white. Okay, B-Y-E. No, B. I think I have a problem with my keyboard. Oh, sorry. I know what the issue is. The issue is that I am on a German keyboard. I've totally forgotten. Okay, so I'm hitting the wrong keys all the time. Right, back to the PowerPoint. Yes, PowerPoint. Right, okay. So ColorForth is still alive, is what I wanted to say. It's still being used, but why? So let's move on. I have a concept called shortening the conceptual gap. Verkürzung der konzeptionellen Lücke. Okay. Auch auf Deutsch. The reason is that I copied parts of this PowerPoint from a presentation I did at the Kustentreffen, or whatever it's called, in near Hamburg some time ago. So, and I thought,
Cforth,
Kustenforth, genau. And I thought I'd keep it in because I know there's quite a few people who are German, or at least speak German. And there's a point to it as well that I want to make later. Okay, so what we have is a computer, and in this case it's an Apple Lisa. And on the right you see a programmer who happens to be also called Lisa. And the idea is that the human programmer has some thoughts, and she sits at a computer and types something, and you want to make the gap between these two things as short as possible, and preferably zero. So this is what it's all about. I mean, what can you do with the computer that allows a person to understand what it is going to do, and so the person can tell the computer what the person would like it to do. So we want to make it as easy as possible for someone reading the source to create a conceptual model of what the program will do when it runs. It's all quite easy, and there it is in German for you. I won't practice my German anymore. So Chuck Moore had this brilliant idea that he would use color to replace punctuation. So here we have the conventional Forth version here with a colon, CB, and CB is short for colorblind, and there's a variable called cblind, and you do a fetch 0+. Anyway, it's a little bit unusual compared to conventional Forth, but it's understandable as Forth. Color makes a new word. Green words are previously defined words, and they are compiled in, etc., etc., in a normal sort of way. Okay, so this is what Chuck did. Now, his original ColorForth source had colors, but it didn't have a new line before each new red word. And I've seen a screen of this, a picture on some website. I can't see where it's really hard to read because there's just one continuous stream of characters. Okay, so while the use of color to replace punctuation is an interesting idea, and Chuck has had lots of interesting ideas, as we know, including Forth and ColorForth and ways to create chips that are not clocked, etc., etc. So unfortunately, it fails as a general purpose programming language in this form because a surprisingly high percentage of people are colorblind. So if I show this screen, now I am not colorblind, but if I were to be colorblind, then I may not be able to read one or more of these 6 numbers. I don't know how many of you are colorblind. We could do a poll later, but it's quite a high fraction. So why the interest in ColorForth? Well, the first thing, as I have already shown, is it's very easy actually to take a ColorForth block in Chuck Moore's original colored only form and convert it into a conventional Forth. I think it was 1 block, 1.5 blocks of code to add that feature. Okay, the reason I'm interested in ColorForth and why I'm sure lots of other people are as well, is that it's not about color at all. Color, it just happens to be a feature of one implementation that Chuck came up with in the early days. But the ideas, the fundamental principles in ColorForth go way beyond color. So color in this context is just one way of conveying meta information. So this actually, when I was watching Dimitri's presentation earlier, I thought, well, there's a connection here. I have to see what it is, but it's I'm sure there is a connection there. Okay, so you can use the metadata, which is like attached to each word, to control what the user sees in the editor, what the compiler compiles, or what the interpreter interprets. I'm hoping people that want to read German have time to read the German, and I hope the German is correct as well. But anyways, so these are the current ColorForth colors and what they mean. So you've got a blank one, which for some reason is called orange in this text, maybe a bug, is an extension, meaning I want to carry on with the same color. Then you have an immediate word, an immediate number, a new colon word, a compiled 30 number, blah, blah, blah. You can read these all, but they all correspond to conventional Forth concepts. Like you've got comments that are white. Chuck used this incredibly efficient system whereby you got colors 9, A and B, 9, 10 and 11 are comments that are all lowercase, comments with the first letter capital, and comments that are all uppercase. So you are compacting this. Every token, everything you see on a ColorForth block screen in the ColorForth editor is a 28-bit value, which is a name, and a 4-bit color. I'm not sure why the yellow immediate number has a 27-bit number. There's probably some good reason for that. Maybe it's signed. Anyways, right. So one of the things I'm interested in, not only in ColorForth, is the idea of reducing the complexity of a complete system but by adding complexity to just specific parts of it. It's a bit hard to explain what I mean by this at the moment, but I can talk about that some other time, maybe. Just to say, this is one of the reasons I'm interested in ColorForth. So I would like to add version control, multi-language, multi-user, test frameworks, etc. Alles auf Deutsch. And the idea of a computer language that speaks both German and English, or English and Deutsch. It's very good. Okay, so here's a picture where I try to explain what I mean by this. This is traditional Forth, like Ants Forth or whatever. You have a person, Lisa, and she is interacting with a text file, and the information that she is seeing on the screen, that's the top right there, and there's a little icon of a conventional keyboard that she's typing on. That information is stored in a file, and you can see what it says there. It says colon, squared, dupe, star, etc. Okay, so then you have a compiler and you invoke the word include, and it compiles that file and it produces some kind of output. So what has to happen here is that the compiler has to read the file and parse the file, meaning it says, okay, what's the first string that I find that is bounded by spaces? And it's a colon. It says, oh, it's a colon. I will compile what follows next. This is conventional Forth. I'm sorry, I have a bit of a catchy throat. I don't think it's contagious over Zoom meetings, but I'll just take a drink of water and hopefully they're okay. Now, here we have conventional ColorForth, or the original ColorForth. Now, what happens here is that the word squared is red, as in RED. And in the block, you'll see I've put angle bracket R, close angle bracket, square to represent the color red, because I'm not convinced that everyone who's reading this or viewing this can detect the difference between red and green, which so anyway. So what happens is that the user has to select the color as they enter the name of the new word in. So you do that by hitting the R key, R representing red, before you type your characters. Okay, so then when you've done the new name in red, it automatically switches to green for you, or you can choose green by hitting G, and then you type things in green. What then happens is that the compiler doesn't have to parse the word squared or the word dupe or the comment n minus n. It simply goes to the block and says, okay, give me the first 32-bit ColorForth token. And it happens to be something that encodes squared for us to read and happens to be colored red. So that means the compiler's job is extremely easy. It just does a switch on the top 4 bits, or the 4 bits of the color. I'm not sure where they are located anymore. And it knows that it has to create a new word with that name. And that's it. So it's very much easier. Okay, but the thing is, that isn't a huge change, but the implication is very interesting. If I go to the next screen, this is ColorForth in colorblind mode. Now you see the block is exactly the same. If I just toggle between here, so you can see what's actually changing. The block is the same in each case, but when you press the F4 key, it says, well, when you see a red squared token in the ColorForth block, if you weren't red previously, i.e. on the edge between a non-red and a red token, please insert a colon and a space. And so that's it. So this concept of attaching the metadata meaning to each word, each string, if you like, in the ColorForth, means that you have the choice to interpret it or display it in a way that makes it easier. So if you prefer that one, you just press F4 again. If you press F4 one more time, it goes to that. And this also opens the possibility of displaying it in some other language, that is some other human language. And this of course is German, and it means squared. So okay, this is one of the things that you are everything resolves around the ColorForth block and the tokens that are in there, and depending on what is in there, that is what your program will do. But what you see on the screen is, in a sense, independent of that, or in a sense can be changed very easily, which is not so easy to do, I think, if you've got a conventional Forth here. If your text file says colon squared and you want it to appear as colon in some other language, I'm sure there are ways of doing it, but they're all not very easy, I would say. In fact, many moons ago on Black&White, I had an interesting conversation with John Passaniti, who many of you Black&Whiters will fondly remember. He was a really good guy, very talented and very strict. And he did explain that he could implement one of the features that were very easy, that was easy to do in ColorForth, which is the magenta variable in Perl, and he did. And I was very impressed, but I think he missed the point in this thing, that the ColorForth magenta variable is about one line of code, and his was about 1,000 lines of Perl, or 100 lines.
Sorry, Howard, we are very short on time, and
Okay.
we have now, we need to get to Leo Brodie presentation, so please, if you can shorten up.
I will do that. Yes, thanks. I'm totally losing track of time. I will skim through there's only a few more screens. Okay. So this is the point there. Yeah. ColorForth is infinitely powerful, to quote Chuck. And okay, just to say that if you want any of the links here to actually try out these programs, they're at my inventio.co.uk site. You can actually just type inventio.co.uk and it will find you my website, and you click on ColorForth and you're there. And I think that's it. Yep. Okay, so my timing wasn't that bad, I'd say, Peter.
Well, this is excellent, because I was listening very, very, I could not stop listening to you, Howard.
Good.
Sure.
Good.
And
Please unshare the screen.
Okay, is that new share at the top? No, new share, unshare. Stop share, I got it.
Stop sharing. Yeah, right.
Right.
I can only encourage everyone to have a second look at ColorForth if you tried it earlier, or have a first look if you haven't looked at it. It's really worth doing it, and don't be frustrated. Go ahead and look what it actually can do. It's full of great ideas.
It is. It's really extraordinary thing. And to think that Chuck and Green Arrays have created chips using it. Anyway.
Right. So do we have time for one question? Is there a question?
Hi, this is Christian. I have one question. Could you post one link that will explain most of what you said today? I want to try ColorForth again 20 years after, because I was totally confused then.
Yeah, it takes a bit of getting used to. The document that you want is the CF 2019 documentation PDF, which you can get from the link that I posted earlier. Can I very quickly share my screen again?
No, we posted in the chat. I think
yeah,
that's
okay.
Reasonable. And then
it's in the chat, okay.
Yeah, you'll find on my webpage something that says latest CF 2019 distribution documentation, CF 2019 ColorForth.pdf. And if you open that, that is my most comprehensive documentation of this.
Thanks.
Right. Thank you very much.
My
Howerd.
pleasure.
Nice talk as always.
Thank you.
And so we continue with our next speaker, Xuyang Cheng Javaforth. Or you explain how it's pronounced, please. Javaforth for robots. So if you're ready.
Xuyang is correct, my pronunciation. Xuyang or not?
Yeah, it's actually, that's how you pronounce it.
Oh, well.
Okay, great.
But that's why I tell people to call me Sean, because it's
Sean,
easier.
wow.
Sean Cheng. Okay, great. Please share your screen. We're very excited to hear your talk. We see a slide with the Forth interpreter, and now can Forth and modern robotics play well together?
We have only 10 minutes, Xuyang. We are very short on time.
I made exactly 10 minutes of presentation. So let's get right into it. I think earlier, some people on the chat were talking about MicroPython and how a lot of forths don't have a lot of the libraries you need to access hardware. And so I think in pretty much any programming community, there's kind of a tendency to make a pure forth, which is when you have a forth that is, you have a single chip running only forth, and you have control over every single instruction on the chip. And while it might not be very practical, it's very fun because you're in control of the system, and it's basically just, you have absolute control over everything. It's your playground. But I think what happens is that you spend a lot of time having fun and building a system like this. And then you say, okay, well, now I want to interface the system with some hardware, or I want to use an existing library with the system. And the library is not written in Forth, because usually libraries aren't written in Forth. And so now you're trying to put this, you're trying to get this to work with your Forth. And I mean, usually Forth is elegant. And so it doesn't mix well with modern software, because modern software is complicated. But I'd also like to say that even though modern software is more complicated, generally it also has a lot more compatibility. It has more support for just everything in general, because most people aren't Forth programmers. And so sometimes you have your elegant Forth and you need to leverage the tools that other people have made in Java or C++. And in that case, you kind of have to reconcile the two languages, Forth and modern software. And this is kind of what I set out to do. And one of the sacrifices I had to make was that you don't get control over your system anymore. Like, it's like you have to deal with the OS, you have to deal with the quirks of other libraries, you have to deal with like threads. And so instead of having the programmer and Forth be kind of like gods over the system, you kind of have to make it play well with the rest of the software. So your Forth isn't a king anymore, because back here in your pure Forth, Forth is the absolute king. Anything the Forth wants, you as a programmer will provide. But in this case, you can't. And so let me tell you a bit about what I do. And what I do is I'm in a high school robotics competition called First Tech Challenge. And we basically compete, right? We build, program, design a robot over the course of a few months, and we take it to championships and competitions. And I don't think I've seen a lot of examples in this community of Forths with modern software, and beyond that, Forths with modern software and hardware control. So there is some, but I just thought it was something that we were missing. And so that's part of the reason why I wanted to do this, which is to kind of explore this area that isn't very much explored. Here's me a few years ago. I'm right in the middle of that panorama. My face is squished. That's us in Houston at the Minute Maid Park, and that's actually for the World Championships. So in this competition, we're using a lot of the modern software stack. So in the case, we're running all our programs on an Android system. And on top of this Android system, everything's written in Java. And so there's a lot of bloat that we have to worry about. But it also means that we have very easy compatibility with pretty much anything. We run things like computer vision, we run neural networks, we do localization, we do path planning, and all of this works out because we can pretty much use any library that exists because it's running on the Android system, and that's compatible with most things except for Forth. So this is, I'm not going to show the whole video, but this is an example of our robot in action. This is autonomous period, which is no driver control at all. So you can see the robot right now, it is scanning an image target on the near wall, which we can't see. But basically, that's how it's localizing to get the very fine heading needed to land that shot into the high goal. Yeah, and so good work and build team getting us a shooter that works that well. And you can see sometimes the image target is in sight, sometimes it's not. And the robot is smart enough to localize whether or not it has tracking. And so basically my point is we're doing a lot of very complex robotics that has to mesh well between the hardware and the software. And so in this case, here's our existing control system. And I'm trying not to make Forth the king in this case. I'm trying to make Forth play well with existing software. And to do that, I kind of have to make compromises on how much control I have over my Forth system. So in this case, not much control because I have to build the whole Forth around our existing control system. And here, the driver and the robot are remote. They're separated. They're not attached by a cable. And so basically the driver is putting in controls in the controller and it's being sent over Wi-Fi direct to the physical robot. And on the physical robot is all of our Java code, which further calls our computer vision, localization, and motion planning. And whenever we need to update code, then obviously you connect the robot to the computer. And so if I were to build a Forth system around this, if I were to build a Forth system to control the robot, then that would mean I need some remote aspect between the robot and the remote driver. And I need the Forth to talk with the Java. That's non-negotiable because well, the existing system is Java, and the whole point of this is to leverage the libraries and the functionality that we already have. So here is my solution. And so as you can see, there's an existing Wi-Fi direct communication between the driver and the robot. So I don't want to disrupt that. And so it communicates over Bluetooth. So I have the programmer's laptop on the left, and it's basically doing peer-to-peer over Bluetooth. And on the robot, there is a Javaforth interpreter that takes these Bluetooth commands, processes them, and it also has a connection to the existing Java code. And this is really cool because Java runs on the Java virtual machine, which means that within Java, you can get state information about the program itself. And that just basically lets me use Forth to invoke methods in Java code and also receive back the returns from Java methods. And also a consequence of this is that the Javaforth interpreter must be written in Java. We don't have a choice here. But right, the whole point is just to explore and see, is this possible? So in writing this interpreter, once again, Forth is not the king. When I was writing my own low-level Forth, I think a lot of people have the tendency to micromanage all of the function calls to save 2 or 3 bytes per word. But you can't do that here. Forth is not the king. You have to get Forth to play well. And so some things I had to sacrifice was, for example, using Java threads instead of a custom multitasker, because once again, all of this is running on the Android OS. and also loop-based next, which is a talk in itself. Basically, you can't use jumps in the Java virtual machine. It's just not designed that way. And also, I didn't really get to finish. It ran out of time. It would go over the 10-minute limit. But basically, this is a multitasker, and each task has its own stack, and it's basically accessing a shared memory. I'm sure a lot of people here are familiar with that, but it's not that important. So before I run out of time, let me show you.
Let's, Xuyang, let me ask Dr. King. He's the next participant. If he wants to allow you to extend your presentation, and we got in the next meeting, Dr. King, this is a question for you. Dr. King, are you in the meeting?
Yes, I'm here. Yeah, okay.
What about we have your presentation in the next meeting because we are very short on time, so Xuyang can continue, or
Yeah,
we stop here.
Well, just let him finish this. Let him finish this.
Okay.
Thank you very much.
Okay, great.
So once again,
Thank you.
Show the video, but here is the programmer's computer. This is the host portion of the remote Forth shell. And so you can see I've connected to the client, which is the robot, and I can send commands. Okay, there's our robot. I can send commands over to the processor on the robot remotely. So here are just some predefined words in my Forth. So the Forth is running on the robot. I'm sending commands from the computer over Bluetooth to the robot. The robot is taking the command, processing it, and then sending back the result to the host. So forgive me for the unconventional word names. This was a learning process in itself. And here I'm calling native methods. And so through Java reflection, I can actually get a list of all the methods available. And what's more is I can actually call these methods. So here I am calling a native drive robot method in the Java code. And so I'm telling it to drive forward, wait 600 seconds, and then set the power to 0, which has the effect of moving the robot like so. And here is what it looks like from the outside. There we go. And so once again, I'm utilizing existing Java methods to move the robot, and theoretically, I basically have full functionality. Through Forth, I can access the full function of the robot, but I didn't have enough time to finish that. Maybe next month I'll have more of our Java code translated into Forth. Anyways, I'm going to make a sweeping generalization here, and my conclusion is that we occasionally have to make Forth compatible with existing software because there's just functionality not available in Forth. And when we do so, it's definitely possible, and it works really well, as you can see, but it comes at the cost of compromising on elegance and control. It means having to deal with a lot of these messy, complicated real-world stuff. And that's about it. Here's the GitHub repo for the code. Here's more information on our robot. And if you'd like to find me after the meeting, I'd love to talk more because 10 minutes was definitely not enough. Thank you.
Thank you very much. Very, very mind-blowing talk, especially the use of reflection that we saw and that we are also discussing in the chat right now. Yeah, that's nice. Are there any questions?
Please unshare the screen, Sean.
Yep, he did. Are there any questions to Sean?
I want to say something. This is fantastic. What this young man is doing here, from many aspects. This is where FORTH should be. It should be explained to the young generation. FORTH should be used in robotics, in automation, in ESP32, in every aspect where we have automation, and this is the goal. This is the best environment to force grow, and grow. And Xuyang is a bridge for these other robotic groups.
Thanks, Peter.
Yeah, I'd like to make a comment.
Sorry, of course you have the next meeting again and again, like well, he is Don. Don is the mentor.
Don also. Demitri has a question, but Don, please, Don first, and then Demitri afterwards, I would say.
Oh, I just want to mention, I love what he's doing. I've known him for several years now, and the concept of using FORTH as the interface to humans, because FORTH is a natural for for using English to talk to a machine. So all of our, I think in the future when we see embedding FORTH in FPGAs so we can interactively talk to an FPGA, which isn't possible unless you do a whole lot of coding. Integrating FORTH in with some of these other, these other tools, instead of fighting the other tools, we integrate with them and we become a communication channel, because that's what FORTH is great at. So anyway, I really applaud what he's done.
Thanks, Don.
Yeah, Demitri.
Oh, my question, this might have been answered in the chat, I wasn't sure, but I was wondering if this FORTH system compiled to the Java bytecode. I think they're both stack-based, so I just wondered if the translation from FORTH to that is straightforward, or whether anyone's done it before.
Yeah, so I think if you search up FORTH, someone has actually tried to write a FORTH directly for the Java virtual machine. So there's a difference here. Java virtual machine is the standard kind of foundation for bytecode. It runs bytecode, and basically Java compiles down to bytecode, but you don't have to use Java to get bytecode. There are other languages like Kotlin, which also compile to bytecode. And while FORTH and the Java virtual machine are both stack machines, it's really not designed to run something like FORTH, because for one, before you call a function, you have to know the maximum recursion depth. Whereas in FORTH, you kind of have like a chain of jumps, kind of have thousands or tens of thousands of recursive calls if you were to do it in the JVM. And second is that functions can only return single things. It's not like a stack where you can put as many returns as you want. So the JVM really is not designed to run like FORTH.
Thank you very much. Are there any additional questions?
Can I just make a comment too? How pleased I am that somebody who is so young is interested in FORTH. If you look at the people here, your hair is not white yet. You just have to wait. It goes white eventually, but it's really good, because I can see the excitement that you have when you type something in and the thing moves. It's brilliant. It's the same feeling I got when I started, and I still get now. So well done. It's really cool.
Yeah, I joined SVFig about like 4 years ago, and actually Dr. Ting was the person who invited me to my first meeting. It was at the Maker Faire back when that was still a thing.
And you see, everybody gets together here. It's the maker groups, Maker Faire. I follow Dr. Ting and Don and everybody at SVFig. These are the guys who have the ideas.
Yeah, I just want to say, Sean, I really applaud that you're also struggling with some of these questions about where FORTH fits into the world and how to reconcile it with software complexity and all these things. These are great issues to struggle with. It's very cool.
I think someone in the chat asked about why you can't have tail call optimization. And just real quick, the JVM is a lot like the C compiler. It's big, it's monolithic, and what's more is that it's fast. JVM has a lot of dirty optimizations, hardware level optimizations, which makes it incredibly fast. But most of it is actually hidden from the user because unlike C, Java code is standard no matter where you run it. So in that case, yes, I'm pretty sure that the JVM does do tail call optimization, but it's just not designed to run Forth. No matter how much you optimize it, it's never going to be really good. Basically, what I'm doing is I'm not writing JVM bytecode. I'm just writing Java, and I'm emulating the instruction pointer. I'm emulating the memory. You just can't run it natively on the JVM.
It's kind of interesting, actually, that from what I recall, the JVM is actually a stack-based machine under the hood itself, but it still doesn't fit one-to-one with the kind of model of Forth. So it's kind of, I think the design that you came up with makes a lot of practical sense.
Well,
Yeah,
guys, I announce Leo Brodie is with us. So Leo, where are you?
Hi, guys.
Hello.
Thanks for having me. Hi, Peter.
Hello.
Hi.
Welcome.
Hate to barge in like that and interrupt your conversation.
Leo, I don't know, this is a friendly meeting, you know, we are going to talk, you are the owner, you are the owner of the group in this moment. I don't know, Ulrich, should we make a 2 minutes coffee break, or are we going to continue?
Yeah, as this was announced for, well, in 3 minutes, maybe it's a good time to just wait for late participants to come in, so that they are not disappointed that the things are already started. I would say, so 3 minutes is enough for me to get a coffee, and I would say we just do it. And then,
Great idea.
Yeah?
Yes.
Great. So then I rush out, and whoever wants to do this, please go ahead. 76 participants I read in the chat. So, well, that's great.
One moment, guys. I come back in 2 minutes.
I just saw John Ribel. Hi, John. It's been a long time.
Yes, it certainly has, Leo. Wow.
There you are.
So much has gone on.
Oh my, yes.
Leo, maybe you could play us some background piano music while we make coffee.
Oh yeah, sure. You see the piano here? Yeah, I should clear off the papers. It looks junky.
I had to get mine tuned a few weeks ago, and I'd put it off for about 3 years because there were so many music books on top of it. I was just too embarrassed to let someone into the building.
Oh, never let that stop you.
When I actually decided, okay, look, we have to clear it out, it took like 5 minutes. It's ridiculous.
Yep. We do that, don't we? Oh, a lot of familiar names. And Bill Ragsdale. Hi, Bill.
Leo, great to see you. Absolutely great.
Yeah.
There has been this 30-year gap in our relationship.
Yes, that's true.
Did you used to live in the San Juan Islands, or do I remember something else?
No, you're absolutely right. I moved from California to an island, one of the San Juan Islands called Orcas Island.
Mm-hmm.
And then it was just beautiful, but it's hard to find work there. But it's kind of a tourist place, but it was beautiful. It was a great kind of what do you call it when you hit your midlife crisis? That's where I kind of recovered from that. And then I moved to Seattle with my son. And
I thought West Sound was one of the most beautiful places I had ever visited.
Oh, it is. It's just a gorgeous little island. It's a gem.
Mm-hmm.
And you're still in Northern California?
Yeah, we retired from Hayward, sold the business 25 years ago. We live in Woodland, California. And at the big times, the kids were a year old, and now they're 35 and on their own.
Yep.
Mhm.
Yep, I've got a 40-year-old.
Yeah.
So are you still active now in puppetry? Is that your main avocation?
No, I had a good fun fling with that, but I'm still doing technical work and programming for my wife's company, but my hobby is music now, full big time music.
As we see the
When I get a chance to, yeah, when I get a chance to do it.
Still get to go to puppetry conventions though? Or is that faded away?
There, I don't do that anymore. But because you know, I don't know. Puppetry conventions are really interesting. Really
I love the photographs you used to post. I thought they were really enticing, actually. Kind of like Mardi Gras all day long.
Yes. Yeah. Yeah, it's fun.
Right.
I'm a little too old for that, though, I think. Not that,
Do
I don't mean...
do you ever link up with Ned Conklin and Elizabeth in Hawaii?
No. I think Elizabeth and I are friends on Facebook, but we never... You know how it is when you have so many people on Facebook, you don't see their posts. So I don't really, and I might not even be a friend. I might just be imagining that.
She does pop up with posts occasionally on Facebook.
Yeah. Well, this is fun. We have 4 pages. I have to click to see you all 4 times.
Yeah.
Well, most of you are not on camera, though.
76 participants. And I must say, I'm very happy. And I was really excited when Peter told me that he talked to you and you will join us, because actually you're one of my youth heroes, writing this and the Starting Forth book, of course. So this is the original one I got some 30 years ago. And it really has content that was amazing. And I think it's still relevant today. And the artwork that is in Starting Forth and also in Thinking Forth really was partnering my whole life. And I came up with your drawings again and again to illustrate also talks of myself. So I'm very, very happy to listen to what you want to say to us today, and also happy to be able to ask you some questions afterwards.
Great. Yeah, I'd be happy to.
May I propose, Ulrich and Leo, we have people very late in the night in Asia. If we start with them and then we go over to Europe and then to the other.
Of course.
Who is in Australia? Is John Hardy in the meeting? Or Rob? Do you have any questions? Rob, are you there?
Yeah, I'm here. No questions at all. I'd just like to welcome you, Leo. You're, as you were just told, you're one of my heroes as well. You taught me everything I know about Forth. So thank you very much.
Great. Thank you. Nice to meet you, Rob.
I'm in the meeting as well as John Hardy from Melbourne,
hi, John.
Australia. And yeah, I first read your book in the early 80s, Starting Forth. And it influenced me quite a bit, because I realized when I did I published a few articles in local magazines, and they had a lot of cartoons in it. And I was going, gee, there's a lot of Leo Brodie in there. When I looked at them recently, I thought this is very much influenced by your style. But yeah, it was just something that it occurred to me when I was looking back through I was rereading your book, and it was just something that popped out.
Well, that's fun.
But, thanks and welcome to the group.
Yeah, thank you. You're muted, Peter.
Can you hear me, guys?
Now.
Hello?
Yes, yes, we hear you.
Yeah.
Where are you?
Hello. My name is Konstantin. Just wanted to tell you that I'm one of those guys who bought your book in Soviet Union with a Russian translation.
Oh.
I'm so glad to meet you here today. So thank you.
You're welcome. I didn't hear what you said. You're one of those people who bought my book. Say it
in
again.
Russian, in Soviet Union.
Oh, yeah. Wow,
in
cool.
late 80s.
Yeah. Yeah, that
you.
was fun to see it
You
translated
can
into
you
Russian.
can see even how it looked like in Soviet Union. It's
have
real
one.
Soviet.
I got a copy of that, which is really fun.
Nice.
So it was official publishing.
It was, I guess, an official translation into Russian. So I bought it in a regular store, bookstore. So.
Yeah, that's just amazing to me. So cool.
Yeah, this is starting forth in Chinese.
I remember that. I remember that, Dr. Ting. Thank you.
Dr. Cheng, where are you? Say hello to our friend here.
Mm-hmm.
Dr. King?
Here. Oh, it's very late in Taiwan here, but I think it's the first I'm here. Because I'm retired for 6.5 years. So I'm now just retired for good. So all the time is in home, just missing the good old days with the boss. Because the Dr. Ting, he's teach us the force in the Taiwan. So in Taiwan we call it the father of the force in here. By the way, we also just get the knowledge is from his book. He write a lot of notes. In the Taiwan, I think the FIG Taiwan have the one good benefit is the hardware, because here is the island of the silicon. So we have a lot of chance to can make the very cheap. So it's in here. I'm just give you an example. If you just want to make a 90 nanometer chip in the 6-inch wafer, now you just maybe just need $30,000 US. You can make the wafer, and you can get every slice just have the $300, and every slice maybe you can cost by I think 50,000 or the 60,000 chips. Of course, you have to pass the package or and some testing, but it means the force is never have been to be a virtual machine anymore, because now we have the chance can make it be a real machine in the low power and good efficiency, and in the better way is the force is in the active language, or we can call it the all-in-one system. You don't have to just put it on the Linux or put it on the big like the Windows or the Mac. That's kind of the huge operating system. If just can do this AIoT or artificial intelligence, the Internet of Things. So in that kind of the project, maybe we can have this chance use the small chip with the force inside. It's a good idea to do that. The second thing is how to teach the force. It's something just confuse us for maybe over the 20 or 30 years, because a lot of professors try to teach the force in their school, in their class, but it's not easy to successful, because when you want to explain the force with the assembly, that assembly is not force. Like the 8086 or the
Okay,
8051.
Dr. King, we continue with Jason in Malaysia. Jason,
Okay.
are you there? Thank you for your talk.
Okay, thank you.
Jason? You are mute. You are muted, Jason. Unmute, please. You are muted. Okay, next one. Is someone else in Asia who wants to say hello to Leo?
Yes, sir. So do you hear me, sir?
Yes.
Okay. Nice to meet you all. Yeah. I'm very appreciate to meeting you in the meeting.
Yes. You're in Asia?
Actually, I'm from Laos and I'm living in Asia. But right now I'm continue to study in the master in the Philippines. I'm doing about the mechatronics.
Oh, good.
Welcome.
Well, is somebody in Russia? Is Ilya? Ilya, are you in the meeting? Do you want to say hello to Leo?
Hello. Can you
Hello,
hear me?
Ilya. Yes, hi.
Yes, I'm prepared some kind of material to continue our lessons about Fort writing. Okay. Last time, nobody knows from where I am, so and I check my home. Sorry, no vodka, so I cannot put it at the background. So I am from Russia.
Hello.
I still not sure. I will tell something today.
No,
but
only say hi to the group, no? To say
okay.
hi to.
Okay, so I can say hi, and I will add at my lecture, starting Fort, thinking Fort, writing Fort.
Okay.
Writing Fort. Good.
Well, so I think it's time. Ulrich, do you want we start with some questions? I talked with Leo to make a kind of interview. We are talking with him and he will tell us about the story, the history, how he created his wonderful books.
Yeah.
What do you think?
Yeah, right. So we were always wondering, I learned you originally have been a puppeteer. And so at least in a German setup, it would be very unusual that a puppeteer would do any technical work. And so we would very much learn about how you came to FORTH Inc. and how you, in the end, wrote these amazing books. Like this is the German translation of Starting Forth. And so I have both the German and the English copies. And so how did it all became come into existence?
Yeah, I think you're going to ask me those questions, Peter. But that's something we want to. I think that'd be fun to talk about.
Yes. Yeah. Okay, Leo. How was the start of your career with FORTH? How did you enter in contact with FORTH?
Okay. Well, I really was lucky. I kind of fell into it. I didn't plan this, but I had this was back in the late 70s, and my first wife was pregnant, and she said to me, you know, because I had been sort of doing odd jobs and still wanting to be I wanted to be a comedy writer, actually, and I was also writing songs. But she said, you need to get a real job if you have a family to support. So I thought, okay, well, I noticed that there were ads in the newspaper for programmers, and I didn't know programming at all, but it seemed kind of fun. So I just got a bunch of books, and I didn't know the difference between just digital electronics, which I studied for a while, which was actually useful to know, and building little things with just IC circuits, you know, and or gates and all that kind of stuff, and then microprocessors, and then these big mainframes. So and you know, mainframes were like you couldn't get near one. Well, I ended up I had a job. It was actually a job in Beverly Hills, California, in an office doing sort of administrative work. And every lunch break, I would go over to a Radio Shack store. So it's a electronics retailer in this country, and they created a computer called the TRS-80. I can actually share my screen and pull that up. Boom, that's it there. Some of you know that. Whoops, go there. Wait a minute. Why is it not coming up? Oh, I see. There. Remember that? So that at the store they had BASIC on it, and and there was a book next to it, and I learned. Oops. Wait a minute. I got to unshare. I'm not very good at this, am I? Oh, I'm trying to unshare my screen now. Sorry. Am I sharing the screen or not?
Yes, yes.
Yes, you are.
Yes, we see it, and we see a small TRS-80.
Okay, I don't know why. Oh, it's over on the other page. I'm sorry. I have two screens. That confused me. Anyway, so I taught myself BASIC, and I thought it was pretty fun. And then I ended up getting a small learning circuit board with a microprocessor on it that Texas Instrument made. And I think I have a picture of that too, if I can risk sharing my screen again. There we go, screen 2, boom. And I'm gonna open it up. It's this one. This one. Okay, so this is just really a single board computer. It had the chip on it, and they had a Texas Instrument calculator face glued to the front of the board so that I could enter the instructions. And that's me playing with this thing back in like 1979. And so I wrote a couple assembler programs on that. One was actually, it played Christmas carols, a couple Christmas carols, using that little speaker that you see on there on the face of it. And the other one was kind of a little check register entry thing.
Leo, could you make the picture a bit larger in the middle?
I don't know if I can do that. Let's see. How do I do that? You want to see that board?
Click slideshow current. Slideshow at the top.
Okay. Okay. I thought I was in the. I see what you mean though. Okay. I'm not sharing my screen though. Now, am I?
No, not yet.
No. Okay. Let me do that again. So it should be. Well, do I want screen 2 or do I want?
Yeah, I think you were sharing your PowerPoint window instead of your presentation screen.
Okay, what are you seeing now?
Yeah, the 9900.
The PowerPoint window.
Yeah, much better, much better.
Okay. Yeah, there you go. That's it. So that was kind of fun. I spent a lot of time playing around with that. So anyway, I did those programs, and then I realized I couldn't get, first of all, nobody was using that, at least not in the area that I lived. So I couldn't find any work doing that. And also I had never been a programmer, so I had no experience. But I had been a copywriter for an advertising agency. I did that for a few years, and I really learned to write well there. When you're writing marketing materials, my editor was just excellent. He just, it's kind of fun because I would write what I thought was a great paragraph, and he would chop out 60%, he would chop out 40% of the words and make it really stronger and clearer. So he taught me to write really well. So I decided I'd be a technical writer, use my little limited programming knowledge and do that. So I saw a job for a technical writer, and it was at Forth Inc. And I didn't know anything about Forth at the time, but I went down, interviewed with Elizabeth Rather, and showed her my little computer board and the applications, and showed her some of my writing, and I got the job. And so I just lucked into that. And so when I was there, I was writing, they had already written, I think Elizabeth mostly wrote a book called Using Forth. And it was meant for technical people. And I sort of maintained that document for quite a while, like adding stuff to it and editing it and maintaining it and updating it. Then Elizabeth asked me to write a beginner book, so that you wouldn't have to know programming already when you read this book. And I remembered when I was in that store learning to use BASIC on the Radio Shack, on the TRS-80, and they had on the table, they had the computer on a table where you could just sit down and use it, and they had a book. And I can't find the book now, but I think it was yellow. I don't know. It was a beginner book on BASIC, and it had cartoons in it. They weren't cartoons that they weren't. There's a couple of them, but it didn't use the cartoons. The cartoons were there just to kind of make you feel comfortable. They weren't illustrating loops or anything like that. They were just like, oh, here's a guy sitting at his computer with his cup of coffee, and it just kind of make you feel, it was so really informal. And I loved the fact that it was written in this real friendly language. And so I thought of that immediately when Elizabeth asked me to write this book. And so I started taking what I knew, and I had access to Chuck, and I had access to all these other programmers. I didn't have much access to Chuck, but he was there if I needed him. But I didn't need it really, because I was doing beginning stuff, and all these other programmers were there, and Elizabeth. And so it was great to have access to that. And they gave me some, simple examples. And so my job was really to try to figure out what's the order that I put all this information in so that it's presented one idea at a time. And the other thing that happened, which is kind of fun, there was a programmer there named Mike Lamana, who was a really great guy. And he said to me, you know what, I've always thought that Forth would be best, the best way to explain Forth would be with cartoons. And I thought, oh, that's an interesting idea. Now I found out later that what he meant was animated cartoons, like films that would show the movements of things like that. But I just thought like a drawing, cartoon drawings. And so that's kind of what gave me the idea to illustrate the movements, because Forth is so, when I'm doing Forth, I remember you have to visualize what's going on because you can't see what's going on. You have to have this mental idea of like keeping track of what's on the stack. You have to do that in your head. And then you have to just imagine all these data structures and things happening and what's the interpreter doing. And so I just thought it would be fun to illustrate all of those things with little characters. And so that's how that came to be.
You answered my next question. This is the key of the success of your book. This is the key.
You're right.
Well, we all love your creativity. It's fantastic, Leo.
Thank you. Well, it was just a way to explain the ideas. Go ahead.
How did you come up with the characters? I mean, the interpreter, it's really a character that we know, or the executor. Did you sit down and said, okay, let's, or how does it come to your mind?
Well, I think, you know, it's funny. I think I was looking through this just last night, which I don't normally read. I haven't read it for a long time, but I was just flipping through it and I was looking at the cartoons, and I actually am answering your question, but most of the cartoons are based on some kind of wordplay. So like I think Peter posted the one about, oh no, he didn't post it. He posted a different one. But I was flipping through it, and there's one where all these, they look like they're kind of drunk, all these programmers. They're at a party and they're dancing with each other, and they're holding drinks and stuff like that. And one of them says, you know, I don't really see how these programming conventions improve readability. And I realized the joke there is just a wordplay on programming conventions, meaning like how you write your code and how you indent and stuff like that. But I was interpreting it as, oh, it's like a trade convention where everybody goes and shows up and has parties. So to answer your question, Ulrich, when I'm thinking of an interpreter, you know, that's a profession, you know, and there are people who are interpreters. In fact, I have a friend who's a Japanese interpreter. And so I pictured a kind of a guy who would be at, you know, at the embassy, you know, very formal, kind of almost like a butler, you know. So he's dressed with his little bow tie. Yeah. So he's very precise, you know, and he's just looking up the words. And then of course, execute. Well, you know, he's going to be an executioner from medieval England.
Excellent, you know? Excellent. And the compiler also, a monk.
Yeah. Oh yeah, the compiler, right? Because the monk writes the scrolls. So it's all verbal wordplay, and I don't know if it translates well. And then there's one other thing in Forth. It's a little embarrassing because back in those days, you know, I wasn't aware of white privilege, or, you know, I wasn't aware how white everything is in my world, in those books, culturally. But there was a show at the time on Saturday Night Live, and I was a big fan of it. And John Belushi had this character where he would come on and play a samurai. Yeah. Yeah. So, and he would just like go into a hamburger place and they wouldn't have the hamburger he wanted. And he would just go into like a samurai rage where he would be tearing everything up with a sword, like a Kurosawa movie or something like that. So we had this, I forget what character he plays, but he's the
actual guy behind the counter delivering the food to the customers.
Well, yeah. Oh, yeah.
Samurai hamburger.
Yeah. Oh, that's right. Okay. But in the book, what does he do? He's like he's divided.
Divided modulus. Yeah.
Yeah. Right. So he's chopping things up in half. And I, you know, in retrospect, I was really just copying the John Belushi character. Yep, there he is. And I hope it wasn't offensive to anybody, but I think I sort of.
I don't think so.
To me, it wasn't intended to be a racist thing. It was just based on this television character, which nowadays might be considered racist. I don't know. But anyway, that was the origin of all the characters.
The Swap Dragon is the most famous one, because are you aware that there's an award from the German Forth community and we have a bronze figure of the Swap Dragon?
You guys gave me a pin.
Right.
Of the Swap Dragon.
So it's
really
very
cool.
famous. So it's something like our pet, and that's passed around from person to person every year. And so the Swap the same, or is there a story behind Swap as well?
What do you mean?
So how did you invent Swap?
I was looking something up here. I just wanted to show you. Well, it's kind of off topic, but let me go back. What was your question? Did I invent?
How did you invent swap? The dragon that swaps the
How do I
top?
invent swap? I don't remember, but it's like he's gonna I wanted to show the movement, right? You have these two things and you pick one up. You have to pick one up so you can pick the other one up and put the first one down.
Yeah.
So it was like, well, what would do that? I don't know. I don't know how I came up with that. I was probably running out of ideas.
Yeah. So now he's alive and he will be. Thank you very much for inventing.
Well, let me show you one more thing, because this is kind of fun. I don't ever get to talk about this stuff, right? Because none of the people that I know in my world know that I've even written these books. So this is kind of fun for me. So, and if you'll indulge me for a second, when I was writing starting Forth, I was working at Forth Inc. So I did it as an employee of the company, and I didn't consider myself an artist. I could sketch drawings and sort of, you know, I mean, I loved cartoons when I was growing up. I really did. But I didn't consider myself a great artist. So I initially looked for someone to illustrate the cartoons. And I had the pencil drawings and the characters already drawn out in sketches, but I was looking for a real artist. And I happened to have gone to high school with a guy who ended up working at Walt Disney as an animator. So I got hold of him and asked if he could do it, and he recommended this other guy. And so this is what came back. Let's see if you can see that. Let me go like that. So this is the interpreter and the executor guy. Now look at how beautiful these drawings are. I was kind of blown away. And the only reason I didn't hire him to do them is because they look just like Disney cartoons. You know, I didn't want it to look like a Disney book. But they're so gorgeous. He added so much personality that I didn't have in my drawings. But I just decided not to do it. And he went on, this guy who did this, his name is Ed Gombert. I never met him, but he went on to do his whole career at Disney, in Disney animation, which I find kind of amazing. But so I ended up not being satisfied with any of the drawings that any of the people that did it. It's just like they were either too stylized in a particular way that just to me was distracting. I didn't want it to be distracting. I just wanted it to be here. Okay, here's a guy. You know, it's just really simple, straight to the point. So I ended up drawing them myself, and I think I did a pretty good job, as it turned out.
Yeah, they look artistic. Yes, they do.
We have a question here from Matthias Koch from Germany. Leo, for you. Yeah. Are you still a puppeteer?
No, no, I hadn't been a puppeteer. I had not been a puppeteer until the late 80s. So I had written both books, Starting Forth and Thinking Forth, long before I got into puppetry. And it was just, I just loved the Muppets and Jim Henson's work with Sesame Street. And I decided I wanted to do that. And it was a new thing for me. And I ended up doing a lot of work for companies that wanted to do either corporations that either had events or they wanted to make videos. So it was kind of like technical training, or not necessarily technical, but just corporate training. And I just really had fun with that. But
Bernd Ullmann in Germany. Leo, Bernd, are you there?
Yes, I'm here.
Do you have a question?
No, not really a question, but a big thank you for steering basically a big part of my career into computer science. Your book really always inspired me, and somehow, unfortunately, I lost my original version and had to buy the newly typeset book, which was typeset in LaTeX, but I still love Thinking Forth. And it's one of the books I still recommend to all of my students because it teaches so much more than just programming in Forth. It teaches a completely different mindset of programming than what is typically taught in universities. So a very, very big thank you from my side and from Germany for your great work.
You're welcome. Boy, that's quite the setup you've got behind you there. That's you could spend an hour walking through what all that stuff is back there. That's fun. Yeah, well, you're welcome.
Yeah, I also wanted to thank you for thinking forth. I think that was it was like, to me, it was just like opening lights. I don't know how to describe it. You know, I'd already been programming in Forth for a while, but once I went through thinking forth, it was just like a whole new way of dealing with the world. It definitely changed things quickly.
Cool. Yeah, thinking that. So yeah, so I wrote Starting Forth while I was at Forth Incorporated as an employee, and I was really delighted at the opportunity. And it sold quite a number of books, I guess, when it was originally published. And so I didn't get royalties from it because I made my income from the salary. I was paid to write the book. So when I left Forth Inc., I wanted to do another book, and I thought, I really thought that there needed to be something not about the technology of writing the language, but the philosophy of it. Like, because it's so different how like Chuck and the other programmers would think about a problem. And so I researched it a little bit, and I read some I talked about it in the book. A guy named Parnas, I can't remember his first name right now, wrote some papers about really the idea of encapsulation. And that to me is such a key idea. And this was really before object-oriented programming became a thing, but his work influenced that. But I think that the things he was talking about are I have found that in my own programming. It's so important to keep everything that's sort of related in one area of your code, and so that if that something changes, like changes with the hardware, well, all those changes are in that little one area, and you can just substitute out a different section of code, or you can make the changes in that one thing rather than having everything spread out all over the place. And I just refer to that as encapsulation. That's one of the key ideas. And I just thought, okay, that was to me, that was really a pivotal kind of idea. And I wanted to incorporate those ideas, even though they didn't really come from, I don't think I ever heard Chuck really say that word, but he did talk about things like refactoring and things like that. So then I spent at least a year writing that book, and a lot of those phone calls that I made with people and recorded, talking to these programmers about how they did it. And it was just, I was just tapping other people's brains. And I had Chuck that I interviewed in person on like at least 3 occasions for hours. So it was really cool. I was very, very pleased with it.
I'm curious if you can say more about that process. One of the most fascinating parts of Thinking Forth is those interviews with you. So these were done over the phone or largely in person? And how did you recorded them, and how did that work?
Yeah, they were all done over the phone, except for Chuck, because I was living in the LA area at the time. So I actually had him in person, and this is a little embarrassing. You guys are I'm going to probably regret saying this, but at the time I had a VHS camera, and I recorded them onto I recorded these interviews with Chuck onto VHS tape, but I used because I knew we were going to do it for hours, and for some reason I was too cheap to want to use a lot of tape. I put the recorder on they call it the long play or LP setting, which means you get 6 hours on one VHS tape, but it doesn't play back very well. And so I never really got good playback. And, it's just like, I've always thought someday I should, and now we have YouTube, and you can put hours of stuff up on YouTube. And I just like, I don't want to have to go through the trouble of trying to make that work, but it would be kind of interesting. And also he was just, he was just speaking off the top of his head. So I took, I played it back and listened to it and kind of condensed it and got it just like the pithy parts in little sections. And, I thought it came out really well in the book form. Does that answer your question, Brad?
Yes, that's thank you.
I wanted to say before, can you listen to me?
Yes, I can hear you.
Create does is object-oriented programming, and this was said much earlier by FORTH than in any other language, no?
Does anybody use that? Create does? I know I kind of use it for some things. Yes, that's kind of amazing. That's really, I think, my only contribution. That's really the only contribution I think I made to the FORTH community, other than the books.
Wow.
But I mean, in terms of code that has sort of lived on. It's kind of fun to have
is amazing. It's simply amazing.
But of course, build does was also there. So in fact, the concept originates probably from Chuck Moore himself, I think.
So it was called Build Does?
Yeah.
Oh, okay.
Before that, yeah.
Yeah, all right. I'm sure that's true. I don't remember.
Yeah, it's kind of an object programming system where you have one data and just one method, default method. And I use that to explain build does or create does in the Cforth manual. Because for modern people, I think it helps to understand what is the value of FORTH. Because yeah, and I use create does also for implementing classes and objects, and probably everybody who uses classes in FORTH does it that way.
Interesting. Yeah, cool. So so what? First of all, I want to do a little plug because this book is in print, thanks to a team of people, including John Hagerhus, if he's on the call. I don't think he is. I don't see him. But anyway, they put it in he wrote to me and asked. This was in the mid 90s. They wanted to be able to reconstruct the book as a PDF and put it online for free. And I held the rights to it. So he asked if I would put it under a Creative Commons license, which meant that I would retain the rights to it, but I would allow anybody to copy it for free. And I thought, well, that's cool because it was out of print. Nobody was going to publish it at that time. But it could live on, and that to me was really, really a great thing. And so it went on, it went up. I guess it's still available because people are still downloading it. It's probably been downloaded, I don't know how many times. But the other cool thing was because they produced a PDF, I was able to take that since I still had the rights to it and add a cover to it and then publish it using a company that does instant printing. So this book is, when you order, they don't have these in a warehouse anywhere. If you order one from Amazon.com or from any bookseller, the order will go to the company that prints it. They make them one at a time. And I just think that's a fantastic way for old books to have new life. And so people still buy them. Every once in a while they come in kind of a slew of maybe 8 or 10. I think must be someone teaching a course. Some teacher assigns the book, and so it gets an order of more than 1 or 2 a month.
Leo, I want to say you something. I was almost expelled from the FORTH community because I was sharing public domain documents which people need for learning FORTH. And I had a terrible experience with the guy who put everything in his copyright. And I think this is absurd for the community. So I thank you so much for what you did for FORTH. And I regret so much this man is still doing what he did with the copyright.
Yeah, well, you know, I just thought it was I really appreciated the guy who suggested it to me. I had never heard of Creative Commons, but since nobody was benefiting from the book, other than the people who already had copies of it, it just made sense. But I also like the idea that I make a little tiny bit of money from the sale of the book, which is fair. If people want a hardback, not hardback, but it's not a hardback, it's trade publication. But if they want the physical book, then they can buy it. And I think it works out great. Very happy about that. And what I'm doing now mostly is music. So I perform and I have an album. That's something that I'd really recommend, is that you check out my first instrumental album. It's called Across the Years. And you can buy it. You can buy digital versions of it and stuff like that. It's sold everywhere. And I think it's really great music.
Well, we will listen to it, of course. We love all you do. You are a great artist, Leo. You have born with this fantastic, incredible mind and heart and your heart.
Thank you, Peter.
So this brings me to a more general question, which is, since you're artist on the one hand and technical writer on the other hand, how do you think, is there a good relation between art and technology? Does it need to go hand in hand, or
Well, yeah, that's an interesting question. I think programming, I'm doing a lot of programming right now, actually, for the company, which is my wife's company. And for the last couple of months, I've just been really like doing 12-hour days, just trying to, and it's all web-based. It's web-based learning tools. So I'm programming in PHP. But to me, programming is extremely creative. You know, it's technical, yes, but it's also really creative because you're inventing stuff. I mean, you have to use your imagination to picture, well, what's this thing going to look like? I mean, there's nothing more creative than that. You know, I mean, it's the same as writing a play or making a painting or something like that. You have to have some kind of sense of what it is you're going for, and then you have to figure out, well, how do I do it? And all art involves technology, really. You know, whatever it is, whether it's playing the piano or whether it's making an oil canvas, you have to learn the technology in order to be able to do it. But you also have to have the heart. You know, what's the feeling that you want to, and I really think that even code applications have I wouldn't say a personality, but they have a character. You know, you interact with something. When you interact with a computer, you're interacting with something that gives you a sense of it, kind of almost a personality, I guess you could say. They are a form of mind, yeah.
Yeah, we experience this often. If you read source code of some person, then you know, okay, it's his style, and you recognize this choosing of the word names or variable names or function names, and also the formatting is something very personal. So yeah, thank you very much for your answer.
Yeah, I'd just like to say that I totally agree with that, Leo, that there was one piece of code I had to work with a couple of years ago, 5 years ago now, that was so awful. It used to make me feel ill reading it. But also I've found pieces of code, particularly from Chuck, that make me feel really happy. I think, wow. So yeah, there's much more to this than just technical things. There is a feeling to it as well.
Yeah.
Oh, and yeah, thanks very much, by the way, for starting FORTH. That's one of my first FORTH books.
Good. Yeah, I want to say something about Chuck more, because I didn't really consider him like a friend, but he was certainly in the circle, and there would be parties and stuff like that. So I got to be over at his house for parties with the company was invited, and the employees were invited, and that kind of thing. And I also got to have some, conversations where he showed me what he was doing so that I could write about it when I was an employee, and then later, with the interviews and stuff like that. And he's a very sweet man, very gentle man, and just really brilliant. And watching him work and listening to him talk, the thing that struck me the most about him is that he just was not concerned about what other people thought about how something should be done. It was just of no interest to him. What was interesting to him was, well, what's the best way to do this? And and it was really, what's the best way to do this for me? So and so what he comes up with, his solutions are completely unconstrained by conventional wisdom. He doesn't come up with something because that's how people do it. It's like everybody does it this way. He doesn't care about that. He's a free thinker. Yeah. Well, I actually in my own mind use the word genius. And I sort of decided that's really what genius is. It's not necessarily really being smart the way we think of it, like having all these facts on the tip of your fingers or whatever. But it's someone who just can sit with it and go, okay, free my mind. Free thinking is a great word. Just free myself of any expectations or how this should be done, and just get in there and do it. Now, I'm not that way. I tend to be someone who looks at, I'm inspired by how other people do things. So when Jim Henson did the Muppets, I just thought that was fantastic. I loved the idea that they could create characters out of little pieces of foam and stuff. And so I wanted to do that, but I really wasn't inventing it. I was really copying it, and I made my own characters, of course. So my creativity was in the implementation of that and the characters, but it wasn't, the idea of it was, I was learning how they did it and then copying that. And Chuck just kind of, he didn't care. He just did it. He didn't care about what other people said was the right way to do things. And I think that and we all benefited from his brilliance and his genius in that way.
Absolutely. And I think if Chuck hadn't been that way, he couldn't possibly have come up, maybe with Forth, maybe somebody else could have come up with Forth, but nobody else could have come up with ColorForth. It is so out of the box. It's painful, but it's beautiful as well. It's an extraordinary thing.
Albert van der Horst, are you going to say something?
Yeah, I have a question. What I was most impressed with, one of the pieces of code I was most impressed with, and it's related to Meta 2 lecture, is the basic compiler published in 4 dimensions. And I have reworked it, and I think what is especially brilliant is the use of separate word lists or glossaries. And now you got vocabularies. I wonder whether the people who are here, very old hands with a lot of knowledge of what happened, if what is published in 4 dimensions is the original, or that the original was indeed written by Chuck Moore himself, and whether that is somewhere available for study. That's a question to everybody, in fact, but Leo Brodie in special.
I don't know. I don't remember that article. Anyone else?
Michel, Professor Michel from Rio de Janeiro, are you here in the meeting? Do you want to say hello to Leo? Michel, are you here?
What do you care? What other
Late.
people think? So Richard Feynman wrote a book called What Do You Care What Other People Think? I never heard of that. That's cool.
Hi, Leo. This is Christian from Canada.
Hi, Christian.
I wanted to prove that the fort still exists even in Canada and even in Quebec where we speak French.
So you're the proof?
Motivation for me to learn English. When I was in college, I studied in French and I studied technology and I learned I developed my interest for programming when I saw the Byte magazine on FORTH. And then I got your book and I got involved with programming. But all of this contributed to me learning English and being able to talk to you today. So thanks. Thanks for writing this book, motivating me in school, and also try to keep on writing. You're so good at it. And one more thing, thanks for being the written word of Charles, of Chuck Moore.
The scribe,
because
yeah.
He's so hard to understand when he explains it himself. He's fast, he's quick, and he's got a mind that has a picture, and we don't have the picture in our mind when he talks.
That's right. Well, merci for your kind words.
Monsieur, c'est un plaisir.
And this is John Helmers from Minnesota, and I had a question about starting forth. The example about the concrete mix.
Yeah. Yes.
That really hooked me. I was a young civil engineer at the time when I bought this book, and that kind of cemented it for me. Yeah, so to speak. How did you come up with that one, or was that one of the programmers?
No, that was one that for sure is one I remembered. They gave, I think Elizabeth gave that to me or someone. It was actually something that they had to solve for some project that they were doing, and so it was a great example. Can't remember what it was showing right now, but I just glommed onto that one, and it was towards the back of the book.
Yeah.
But no, I didn't come up with that one.
Okay. Yeah, the unique thing for me was it made me click in my mind about you don't have to do everything in decimal. You know, it was an integer calculation of something that needed more precision, and the technique that was used was eye-opening for me. So that helped me throughout my career.
Yeah. Well, again, that goes to when I say I was lucky, because I was lucky to be working there and have access to that, because I would not have been able to think of an example that good to show how you could use ratios with two numbers instead of a floating point. That's how, it's normally physicists would think that way. So.
Ricardo is here. Ricardo, where are you?
I think Greg raised his hand, and so.
Yeah.
Greg.
Can you hear me?
Yeah, you're not close to your microphone, but I can hear you.
Okay. Yeah, I was fiddling with it. Pleasure to meet you. Thank you for the books. I actually stole your book. Actually, I appropriated it from my first employer. We got your book in, and there was some interest in using Forth because we were developing automation systems using PDP-11 assembly language. And unfortunately, there were other corporate pressures which dominated, so that it never really caught on. But I still have that copy. So
well, good, because the company didn't deserve to have that book. So
and I bought several others. I have too, so I paid for them. myself. And actually, when I got the book, it motivated me to try to write my own Forth. And so over the years, I've done that a few times. But that's what really started me. That and the Byte article. But I wanted to ask you. So do you have an Aunt Min and an Uncle Max?
No, no. Again, that's just wordplay. But it's interesting. It was interesting because Chuck's wife's name was Min. She was really a sweet lady.
Yeah, that's right. That's right.
And so,
I saw that on his website.
but it wasn't. That was just, again, it was just a word play joke.
Yeah, I'm just kidding.
I know you know
they
that.
Seem like they seem like very nice people. I would
nice
love
people.
to meet them. But actually, my real question is, I don't know if you've kept up to date on modern programming trends and practices at all. If you had any thoughts on things like, for example, the recent resurgence of functional programming, or any thoughts on the way software development is going these days?
Not at the moment. When I was around in the early 90s, I was doing program management for tech companies in Seattle. And so software development methodologies, Agile and those kinds of things, I did study those. But it was more about, like running a software development team kind of thing, more than the, more like the life cycle of software development rather than specific techniques. And since then, I haven't paid attention at all. I do, like I mentioned before, I do all the work that I'm doing now in PHP with MySQL and some JavaScript and jQuery, and then MySQL. Did I already say that? And some Apache front end, that kind of thing. So, and since I've never worked in that capacity, I've done all this work on my own. It's my wife's company, and I'm the entire technical staff and QA and everything else. So nobody in the company really knows. I'm really on my own. And so I kind of developed over the years my own way of doing PHP. And I think if I were ever to have somebody else work for the company and look at my code, they would probably go, what is this guy doing? But I came with ways of, factoring stuff out so that you could maintain it. That to me, that's the most important thing, is be able to maintain the code. So I think I'm in my own world here, honestly, when it comes to that stuff. I'm just doing what makes sense to me.
Right. That's very different than being on an Agile team.
Yeah. Well, but the stuff, the Agile stuff, the Agile, I mean, I think a lot of the way Chuck worked was Agile. Mm-hmm. So a lot of that stuff really totally made sense with what I knew from Forth Inc.
Can I just make a comment? Sorry, after you. Or shall I just make a quick comment that a couple of years ago, I helped my wife with her work programming in PHP, and I found that I could program in a Forth-like way in PHP very easily, and that was good, more easily than in C or C++ or anything else. I don't know why that is, but it felt comfortable.
Did you like writing short functions and that kind of thing?
Yeah, short functions. You can organize it in the same way that you organize Forth, and obviously you can't pass things on the stack, but you're calling high level routines, so you don't need to pass that much pointers to something else or whatever. Yeah. Anyway, interesting.
Yeah, we should have a beer and talk about how you do that. How you did it.
Or just to say, were you at the Forth Inc. 10th anniversary party in LA in, was it 1983? Because
I don't remember that.
I think I met you there briefly. I was the only guy from England there.
Yeah,
it's a long time ago, and I'm a bit vague as well. But anyway.
Yeah, I don't remember.
Anyway, that was fun.
Well, nice to meet you again.
Yeah, thank you. Just when you said we should have a beer, yeah, let's do that sometime. But
sure,
might be problematic at the moment.
At the moment, yeah. Someday.
Look forward to it.
Hi, Leo. I'm Ricardo from Brazil. Can you hear me?
Oh, hi. Hi, Ricardo. Yes.
Very nice to meet you. I read your Thinking Forth book some long years ago. Well, you know, it was great. It was one of the books that really pushed me forward. So I just would like to say my thank you. Thank you very much.
That's sweet. Thank you. It's really nice to hear. It really is. I never get tired of, you know, I don't know, just be philosophical a little bit, but they say that we never know what impact we have on other people. You know, just, you know, we never know what other people are going through. And we just never know. People see somebody else doing something nice or whatever, or creative or whatever, and it can be inspiring, and the person who did it never knows that. And I have again the good fortune to, at least in this realm, see and hear from people like you who can express that, and I can hear it. And so it's like, well, that's really cool.
Thank you.
Yeah, without knowing, people like Leo and Chuck entered into my mind and into my heart, because he did a creative, so he did such a creative work. If you are not touched by this, I think you don't have a heart, because we all were touched. All who are in this meeting understood FORTH and the people behind FORTH, thanks the work of Leo.
Cool. Nice to be part. Geez, a lot of, I'm enjoying the comments. I'm not taking the time to parse them, but I'm going to have to, before the meeting closes, I want to copy all the comments out so I can read them later.
Yeah, I think you'll get a lot of people saying that I mean, they had a huge impact. I mean, FORTH does generally, I think, on people, even if they end up not using it in the future. But Thinking Forth especially is one of the books, and other people have said it already, that it put together a bunch of ideas that's still relevant today, I think. You know, and a lot of things like, you know, object-oriented programming that allow people to encapsulate stuff, that the ideas in that, I mean, people get hung up about a lot of things in OO, but you know, binding a problem, engineering and software engineering and writing programs is about controlling the problem you've got, you know, down to and Thinking Forth, it just packages the ideas up very nicely into an understandable concepts that you can give to somebody and go, look, it's FORTH. I know you don't know FORTH, but have a look through, and it's sort of even experienced software engineers gain something from it. I think, you know, Thinking Forth especially is a real gem of a book, and I've seen it said many times. So thank you for that.
Thank you, Rob. It's nice to hear.
I have another question, if you'll indulge me. I'm sure. I know that there's the infamous Eggmaster object, and I know that you've sort of, you know, had varying thoughts in object-oriented programming since then. But regardless, I'm kind of curious, what was the inspiration for that particular motif around the thing, regardless of what you think of it since?
So I kind of remember the idea was there's like one thing's like, looks like a blender, and then it has a switch with 3 settings on it, and it's like, but they're completely different things, isn't it? Is that what it is?
There's buttons to pick what kind of egg, but then the caption is
yeah, not it's the egg machine. Yeah, I know, it's a giant vending machine. Yeah, that's I was mixing it up.
Yeah, but the picture is still relevant. I have been working with the system development kit for the Pico, Raspberry Pico, and it's really that experience. So whether or not it's related to object programming, it is just very pedagogical, that picture, I think.
Yeah, I think it's coming back to me now. I just saw it and it flashed by my eyes. My life passes before me when I flip through the book. oh, it doesn't matter.
And the washing machine example, Leo, also.
Well, oh, there it is. This is it. So this guy, it says everything you need. So he can select all these things, fried, poached, but he can't make it himself, right? He can't time exactly how long the egg, when it starts to curl and it's just wants it just right. He can't do it. He has no control over it because it's all locked in this machine. And it's convenient, but I think I got the impression, and this was really with, I mean, I wrote this in 1983 or something. So it was before I'd ever used, I don't even think there were really object-oriented programming languages. That certainly wasn't, like Java came out later. So I didn't really know much about what I was talking about, but I was aware from people at Forth Inc. that if you lock libraries up in a way where people can't access them. I mean, I do have this experience where you buy, well, for example, I'm building, the tools that I'm building in PHP are for training, for learning, so that you get reinforcement tools. So you learn something in the corporate environment and then you get to practice it or whatever. And so I'm building those kinds of tools. And there's all kinds of things that are available that you can buy, software that you can buy it off the shelf. And from a business point of view, it makes so much more sense to buy something off the shelf than to write it from scratch, right? If you can find the thing that does exactly what you want it to do. And that's the problem. I can never get past it in this particular environment. I can never see where people are building the tools that are doing exactly what I want them to do. So it's almost easier. It's been seemingly easier for me to just create the thing and then integrate it and do whatever I want to. And I keep having to change it because we change our mind about how it should work or whatever. But you couldn't do that if you bought it off the shelf. So that's really the idea that I think that Eggmaster thing is trying to convey. Even when you write your own code, the purpose is not to, because they talked about hiding information a lot. Like hiding stuff is a good thing. But to me, that was always kind of missing the point. It's not really so much that you want to hide it. It's that you want to encapsulate it so that you don't have to think about it when you're thinking about this other thing. But you can think about it if you want to think about it. I think that's kind of what I was showing that in that silly picture. Thanks for asking questions like this, though. It's fun.
Well, I personally want to thank you. My book from the middle 80s, it really changed my mind on how to write code. Now, I was not trained in a school to write code. I just learned it on my own. And typical of that day was C procedures that just went on page after page after page after page. And when you got to the bottom, 10 levels of indentation. And once I read your book, I stopped that. I started writing shorter routines, not passing a million parameters, and things went for the better. Thank you.
Great. I still seem to be, well, in PHP, it took me a long time to learn how to.
Yeah, Leo.
Kind of a, yeah.
You have a slideshow. You just begin 2 slides. Will you please show the rest of it?
Well, it wasn't really meant to be a presentation. I thought people would ask certain questions, and you did. So there's really only one more slide.
We have 3 questions.
Okay, this will take a second. I'm going to answer his question. Let me do let's see, from current slide. Okay, here we go. It's on the wrong. Sorry, this is so confusing to me. I should know better. Okay, here we go. This is just the only other slide I had.
That's not showing right now.
No, I think, there we go.
Yep.
Okay, thank you.
So can you see that? Oh, that's going to be partly obscured, isn't it?
No, it's great.
It's great. Okay, so I got to work with Chuck when he built, this was the Novix chip. in the mid 80s, I guess. And I can't remember the name of the other gentleman, so I didn't really show him much in this series of pictures, but he was working to design this self-contained Forth chip called Novix.
Bob
And
Murphy.
Bob Murphy, that's right. Well, I wouldn't have remembered that, but that sounds right. Anyway, so I just thought this was a fun, I don't have many pictures, this thing. I don't have any pictures from my time at Forth Inc., at least that I can find. But I took these pictures when we were doing that thing. And so I just thought these were really fun pictures of Chuck. So I just wanted to share that. Because you can kind of see the joy that he's got. He's just so enjoying himself doing this and thinking about it. It just really captures his personality. So thank you for asking me to show the rest of the presentation, because it wasn't really a presentation, but that was the other thing that I forgot about.
Great. So I think Greg, please go ahead. So he raised his hand, and Greg, do you want to ask your question, please?
Oh, sorry, I must have raised my hand by accident. I apologize.
Okay, man. Then we have Philip. We have Philip.
But I'll let somebody else speak.
Yeah, Philip, do you want to? Here you go.
Don's been waiting for longer than me, so I'll invite him to speak first.
Don, come on.
Yeah, I just wanted to say, first time I met you, but you so impacted my life. I was a hardware guy, and I built my first computer, the Simpet, I think it was, and the Cosmac Elf, and I didn't know how to program, so I went to school and learned Pascal, only to learn the art of programming, and then Forth was actually the first language I wrote real programs. But before I wrote my first programs, I read Starting Forth and Thinking Forth. And the thing I got out of Thinking Forth was you don't write programs, you create a language to describe your application. And you factor your code, compartmentalize your code, and it's hierarchical in nature. And those concepts I got out of Thinking Forth. The rest of my programming life, I've used, even in C, I have tons of small C functions. I don't have pages of them. So even in other languages, it's been, I put on a fourth class here, and everyone who's on, on the Zoom today, all new programmers, read Starting Forth and especially read Thinking Forth. It is how to program, and doesn't matter what language you use. The other last thing I want to say was I had a company where I had a Forth-based robot called Whiskers, the intelligent robot, which I sold into tech ed. And there's probably 50 to 100,000 young kids in junior high and high school that wrote their first programs in Forth on that little machine. And I often wonder about the impacts, that my little robot, did in their lives. I have no idea. I never hear from anybody, but it's cool. So thank you very much for those books. They are fantastic.
Oh, great. Glad to hear that. And now we have Philip.
Yeah, hi there, Leo. I'm interested to know. Actually, just a little backstory to it. My first job out of university in 1991 was for a local company that was doing software and hardware engineering. On my first day of my first job, they sat me down at a desk, gave me a 286 PC and a little single board computer with a Z80 in it that were connected via an RS-232 connector, and a copy of your book, and said, read that, program that, we'll come back in a week, see how you get on. And that tidied me over for about 10 years. I then had a hiatus from Forth for 15 years and then came back to it 4, 5, 6 years ago and having fun with it now, actually. But my question is to do with those days, I suppose, really, when you were writing those first two books. Chuck's views on Forth and how it should be used, quite forthright. And as you've mentioned earlier, is a free thinker. He thinks about what's right for him at that time and doesn't really care what anyone else thinks or how someone else might use it in the future. He's doing it for now. And I only read Thinking Forth about a year and a half ago. And it took me right back to 1981 when I first read your first book. And I thought, who wrote this? Was it Chuck or was it Leo? And I was trying to work out, because reading Thinking Forth is actually quite it's quite a revelation in a way. It's got some very strong thoughts in there, and it's quite a hard read in that respect because it makes you think a lot. It's got some real gold in it. My question really is to do with your thoughts and Chuck's thoughts. Was there any point in the time when you were writing, especially Thinking Forth, I suppose, because that's probably after the initial great impact to your brain about what Chuck was doing? Do your thoughts diverge regarding what Chuck's thoughts are and what you think? You look back at it and think what he was doing there was not right. I think he should have done this, but I wrote it this way or wrote it that way. How was your thinking at the time with comparison to Chuck's?
Oh wow,
it's hard when you're working with a genius, as you called him, I'm sure, but
yeah,
you're allowed your own thoughts.
Well, I can't say that I ever felt like Chuck was wrong about anything. Thank God. I just can't imagine that. So it wasn't like I felt like I was divergent from him. But on the other hand, I do think that I sort of added, you can't help but add your own take. And
you added approachability.
Well, that's true. That's true. I think some people have said that I was his kind of Chuck's scribe in a way. So I put into words what he probably wasn't bothering to put into words because he didn't necessarily care if other people got it. And it's just I happen to be a very verbal person. I just love words. So I think that's probably thank you, Bill. That's probably the main thing that I did. It wasn't oppositional. Right, it was just more in a different way than what he was saying. I do remember though that the work that I got from that reading the computer programming literature at the time that was really coming out of like universities. Some of it didn't seem useful at all to me, but some of it did. Some of the theoretical stuff really did, and I think it helped. Again, to explain what Chuck was thinking kind of in those terms that some of the academic people were using. So yeah, so I don't remember ever having any opinion. I can't imagine where I would think, well, Chuck's just being silly there. I don't really agree with him on that. That didn't happen.
Okay. No, I mean, it's interesting. Yeah, it's pretty much answered my question, I suppose. The reason that question came to my mind is because if you listen to how people are talking about Forth now and in the last few years, there's people that think what Chuck did was absolutely right and don't want to deviate from his practices. But computing itself has moved on so much. And as we saw earlier on in one of the presentations, making Forth work with Java, which in itself is not new anymore, but it's still it's contemporary and people are still using it in production systems all the time. I mean, I've managed teams that have got lots of Java engineers in. I can't fit Forth into there because it's not my corporate language, but it's very different. And now I think trying to fit Forth into current thinking is very difficult. And if you use Chuck's thinking now, it's never going to go anywhere, and it hasn't. In that respect, sadly, you have to really go out of your way to make Forth fit into corporate thinking these days, and that's not Chuck's thinking. So you've got people on different opinions. People say it's pure language. You should think how Chuck thinks. There are people saying that no, he's stuck in the past. We've got to do different things and have libraries and expand it and make it bloated, unfortunately. And it's just a way of life. And it's an interesting dynamic that we've got now, I think, with all this. How does Forth stay relevant?
Yeah, the only thing that I can comment that listening to your question is that there's always a danger where someone comes along with some ideas and then it turns into a religion or it gets codified and people pick some of the superficial aspects of it, and they think, oh, it's got to be this way. This is how it's got to be done. And Chuck would never think that way. I happened to watch part of the recording of this meeting here a month ago that Peter posted, and there was a lot of conversation about blocks, and like it has to be a certain length, and it was like I was a little confused by what people were spending so much time talking about blocks, because because it seemed like they were talking about blocks taking up a lot of memory, but they don't, except on the disk. They don't get compiled, so I didn't understand why it was a big deal. But to Chuck, it wasn't a thing that was religious. It was just, well, here's a very smart way, a really simple way, mainly a simple way to be able to store things on your disk, on your floppy disk or your hard disk or whatever, without having to have an operating system. And there's nothing magic about it, you know. It's nothing, and it isn't. I think Dr. Ting said in the recording, he said Forth is not blocks, it's not. So I guess that's what your question is reminding me of, Philip, is that the person who creates the thing, like Chuck in this case, is never dogmatic about it and would never insist that you do it a certain way. He just thinks that in every situation there's a good reason to do it. Nowadays we can do our programming on a laptop and have a massive file system, and it's no, as long as you can compile to an embedded system, it doesn't matter what you're using, it seems to me.
Yeah, just lastly, a very, very little tiny story about blocks. 2 years ago in FORTH 2018, there was a couple of people in this room now that were at that meeting. I gave a little presentation on a Forth I was working on at the time. I think there's about 20 people in the room. And I said, how many people here are using blocks anymore? And there was one person that put their hand up, and that was Chuck. He was the only one.
Why change, right?
Well, yeah. I'm surprised he hasn't come up with another alternative yet.
Well, actually, he uses screens in ColorForth, and that's reasonable.
Yeah.
The screens are blocks.
Yeah.
Essentially, one view of a block.
Well,
yeah, I use screens as a library mechanism, and it works very well. I have one library that works at the same time for Windows, 64 bits, Linux, 32 bits, whatever. So blocks are a practical solution for things. Let me say that.
Yeah, I think that makes sense. What are people doing these days with the ESP32 thing? I mean, is it, Peter told me that it's mostly hobbyists now that are using it, and it's, I had never heard of the thing before. It's like a super inexpensive.
The FORTH community is following development of Brad. Brad is here with Dr. Ting and Don. And we are following an excellent force. And I invite you, Leo, to experiment this force with us and talk about in our future meetings or in the FORTH 2020 page. Probably we can do something with music and force and the ESP32 force.
Yeah, Leo, you gotta listen to Dr. Ting. He created some incredible music words. Take a look at his video, or maybe Dr. Ting can actually do another thing on that. But we are also, see, I think the future of FORTH is very bright. Talking about blocks is like, you know, you're lost in the forest, you know, you're lost in the weeds. Blocks is nothing. What's important is, in the future computers, do we want our AI robots and our computers to incrementally remember things like humans do? Do we want to be interactive with them? When you think about the the way that Forth is designed, you know, it's a KISS. It's very simple, but it's very powerful. No other language today has those attributes. And we're now moving into where we're going to be working with AI and robotics side by side. And, you know, if we're going to build an AI brain, it needs to incremental compile. I work in the space industry, and we're designing robots that are going to be manufacturing in other planets. I'm the computer designer for the company. And so they're designing all this stuff in C. Well, you have a communication link that's going out to Pluto, and it's maybe 100K link. You know, it's not broadband like here on Earth. So if you want to change the code, just one little piece of code, you gotta ship up there 1/4 of a gigabyte of code to each robot to update it. Whereas if Forth is running in there, you're gonna update maybe 100 bytes of source code. So I think there's a lot of conversation about how Forth is obsolete, it doesn't have a future, and I completely disagree with that. I think that, you know, in computer science, the computers have gotten so freaking fast, so powerful, you know, 16 gigs of RAM comes in your laptop. They don't care. They don't care about utilizing resources efficiently. But then, you know, you pull in a library and your code explodes the size of your code. Try to learn C++. I know there's C++ programmers. It makes my head explode. I'm a C programmer. I write embedded C, and C++ to me is very kludge machination of if you take thinking Forth and you apply that to what object-oriented programming should be, you know. So I really think Forth has a bright future. We're using the ESP32 as a base. I'm coming out with a new robot that's based on the ESP32. It's just taken me way too long, but anyway, I'm still working on it. And Brad and Dr. Ting are helping me, and we're converting over the language operating system. I call it the Triune OS from that robot to this new one. But when I was writing that operating system, I always thought, when I was choosing the words, how would I talk to my robot? And so I made it very conversational, like what you always promoted in your books. You know, don't use some computerese, you know, wash her, you know, on, wash her off, you know, stuff like that. How would you talk to your computer? So I think you would find our group very, very interesting. We got incredible people. Every time we have on these Zoom meetings, I learn so much.
Cool.
I'd like to add a couple of observations. I've known Leo since way back, and I've been fortunate enough to call Chuck a friend for the past 40 years and have worked off and on with him during that time. The two pieces that I've taken, first, Chuck wasn't interested, as Leo had said, of what other people thought. He was writing a tool for himself. He was actually pretty amazed when Silicon Valley Fig, Fourth Interest Group, took off with this thing and it just spread. That was much more than he had ever imagined. He was wishing that millions of people would use it. He thought that it would be an environment in which actually safe programming could run the tools of war that were being run by very buggy software at the time. The other piece is that I've viewed Forth as probably the only working class language. Almost all of the other computer languages have either come out of groups or out of academics that have thought about the theory of the whole thing and put it all together. No, Forth was bottom up, and Chuck just worked to solve one problem at a time, and things accreted and ideas sort of stuck together. Some were discarded and others were added in. It's a very practical environment. And I've got to, Chuck has sort of become much more of a recluse in the last 10 years and is quietly off doing his own thing again, having abandoned ColorForth and gone on to a whole different area himself. And that's basically what I wanted to add into this group today and pass on. I'm not sure, Leo, whether you've probably not had any contact with Chuck over the past 10, 15 years, right?
No, I haven't. Thank you, John.
I hope
that's interesting.
I hope that Chuck will share his new ideas, because I think ColorForth is really hard work, and something easier would be nice. But I haven't found anything easier.
No, he did actually at Euroforth and also at the SVFIG meetings. He gave talks about his new approach, like the subscript and superscripts, and so very, very interesting to see. So it's on YouTube. So
I must watch the video. I'm out of touch with that. Thanks.
Yeah.
And it's even, Howard, it's even more difficult than ColorForth. It's more ideas in one thing for your brain to try to comprehend.
Okay, that has not cheered me up. I've just spent the last 20 years grappling with ColorForth, so I've got somewhere else to go now. Okay.
The new keyboard of Chuck is very interesting. All keys are deleted. It's all blank, a blank keyboard.
Well, that's what we already have in ColorForth with this little keypad. Really, you can change it. Yeah, awesome, excellent. No, I'd like to share as well what's something connected with what Leo was saying earlier about Chuck doing his own thing. I had an email exchange with Chuck back, must be 15, 18 years ago, when I was starting to investigate ColorForth, and he had used one's complement maths in ColorForth, and this meant that that his word "or" was actually doing an XOR or some such. It was very complicated. So I thought, this is strange. Why is he calling XOR or the other way around? And okay, so eventually I looked up what this one's complement was all about, and when I found out what it was, that you can have a +0 and a -0. It's an alternative way of representing values, an alternative to the normal two's complement. I realized that actually one's complement is extremely good. And having just seen about the Apollo computer, I believe that used one's complement, because I watched that video. Anyway, sorry, I'm getting lost here. Anyway, so my point is that I first thought, oh, maybe Chuck hasn't got this right. And then when you dig deeper and understand more about why, then I suddenly realized that yes, Chuck is right. Whether you can apply that these days is something else, but that's some other issue. So yes, I always believe what Chuck says. But what I really learned from Chuck in the email exchange wasn't whether I should use one's complement or two's complement or call X or not. It was that I should think about it myself and do whatever I wanted. So that's something I took away from that.
Yep. Well, maybe we've got everybody's talked out. You guys can move on.
Yeah.
That was really fun.
Thank you very much, Leo Brodie, for joining us. And
It's my pleasure.
I was very happy to I had the chance to talk to you and listen to all the explanations. Yeah, applause, applause. Thank you very much. And the chat is full of discussion and things like, yeah, like that.
Yeah, I'm gonna go. There's a little thing you can click in Zoom that saves your chat to a text file.
Exactly, exactly. I do this frequently, so I get the copy.
Well, Peter, thank you
Right.
for reaching out and inviting me to this thing.
Leo, you are invited in every meeting. Please, if you find another free opportunity to share, to meet with us, please come, and we are delighted to see you. It was one of the best moments in the last years for my life to see you. You were an inspiration for me with these books you did. And this nice community we are building, you are a mentor. You are a mentor. You must keep the contact with the group, with the guys here.
Thank you. I feel very welcome.
Thank you.
All right.
You are.
Thank you.
I'm going to sign off, and you guys can all take another 5-minute break or whatever you want to do.
Yeah.